Hello. Are we live? Possibly, maybe. Looks like we have people. So, welcome to today's work stream. I'll be working on getting Asahi Linux, the bootloader for Asahi Linux, to a reasonable point. So, last my night, Apple released the macOS Big Sur 11.2 Beta 2, which is the first version to actually include the tools we need to run our own code. And I did a little demo on my MacBook Air, and I had been working on this thing I call Mini, which is m1n1, which is going to be our playground and bootloader and tooling for making all of this work. And I did that on the MacBook Air. I tested it here. I did it on the MacBook Air. I updated on the MacBook Air and copied the tool I needed to the Mac Mini to test it. And I just realized now that the MacBook Air is no longer booting macOS. Because what I did is I updated the fake Linux. I have two installs of macOS, and one is, quote, Linux. And that's the one I replaced the kernel on. And I updated that one, and now the other one's not booting. So I haven't actually updated the Mac Mini yet. I was just copying the tool. So I'm doing that now, which is why you can see the Mac update on the corner. And also, clearly, Mac updates spam a lot of stuff on Serial. That's interesting. But I should be recording that. That could be fun. But it's just open directory crap, though. I wonder what that's going on about. That's a capture card on the Mac Mini. And so if this stops booting my, quote, Linux drive, because I'm doing it backwards on the Mac Mini, I'm updating the macOS partition and not the fake macOS Linux thing, then I had to reinstall macOS, and then I might have to reinstall macOS on the MacBook Air, but we'll see. Maybe this can derail into a little experiment about whether, for some reason, the Beta 2 firmware cannot boot Beta 1, or whether something else went wrong. Anyway, while that's updating on the Mini, and macOS updates take forever, it's so ridiculous. Let's just write some code here. So I will actually show you what I have so far. So don't need that. And that was just some experimenting yesterday. So basically this is what I have of a bootloader so far. It's really just a little bit of ARM64 startup code, a little bit of frame buffer code to put the logo on the screen and convert the color format. This is the relocation code, which is because the kernel can be loaded anywhere in memory because they enforce KASLR, so this takes care of that. And that's actually what I spent most of the time working on before Apple released this. I was just testing in QEMU just to prove that this is like generic ARM64 stuff, but I've never written ARM64 low-level code before. I've done a lot of ARM32, and I've also never properly relocatable ARM64 codes, so I had to make that work. And just some boot arguments things here. These are just the standard string copy instructions. This is copied from the public domain C library. Just some types. This is mostly for Mini. And let's see. Actually, is the microphone kind of noisy? I think it's just my computer being noisy. How much I can do about that? And I feel like there's a lot of background noise, but anyway. It doesn't even support receiving over UART yet. It only sends, but it works. These are also just copied and adapted from the old Mini, hexdump, and sprintf, and this is a VS sprintf that has been lying around for like over 10 years now that I've modified and hacked up to remove floating point support because we don't need that. This is just like very, very basic scaffolding. That's all we have so far. So what I want to do while this updates is copy around some of the UART proxy stuff. So the goal here is to... you said there's a lot of noise, right? I wonder where that's coming from. Like, hold on. Like, where... Is that just because this is too high? Nah, I mean, is that better? I think maybe the gain was just a bit too high, and like the compressor was sitting too hard. I think you're just hearing my OBS laptop with the CPU pegged. Yeah, there's an aggressive voice gate that you can actually see it here. So, but I mean, as long as like my voice gets through, yeah, I think the gain was just too high on the input, and it was picking up too much noise. So as long as like those sounds make it, it's fine. Yeah, I think it was just a bit too big. Hold on, let me lower it a tiny bit more, and as long as I'm aiming at the microphone, we should be good. And maybe point it less towards that side. Actually, ideally, I would move this more sideways so it rejects more of the laptop noise, but whatever. I think we'll be good. Something like this. It's just my OBS laptop is currently making a lot of noise because this is on OBS on a different machine. And oh, hold on, I know what's going on. It should improve now. Yeah, hopefully that improved. I had a runaway process eating more CPU than OBS on that machine. Hopefully the background noise is better now. Okay, cool. Let's get to work. So, yeah, that's macOS updating there. So yeah, I want to copy around. Close this. Actually, now it's a bit too low because now you won't hear me when I'm not pointing at the mic. Yeah. So I have code called m1n1 somewhere. Yes, here. And this is what I want. And proxy.c and .h. So this was from a time way back when I ported Mini to... actually, hold on. First of all, let me make sure this builds... I don't need that. That's some junk from I was testing earlier. Yeah. Something like that. And this will actually be the initial commit. Cool. So this UART proxy stuff is going to come along for the ride. And as you can see, it's basically memory reads, memory writes, and then there's a separate thing called the proxy, which does specific operations. So this is coming along. Just copy these to Mini. You can probably make this a bit bigger and less wrappy. Oh yeah, because Git, I guess. I'm not losing anything here, am I? No, it's fine. I think it's just confused by the Git thing. Cool. What did Kate do to me? The STFU. Yeah, okay, so this is what I want. UART proxy, so wow, that's updating. UART and proxy. This is not going to build. Nope. Graphics. Yeah, we don't have graphics, do we? I was messing with the GPU on the SPMP, so I have a render bunny operation. I don't think we need that. And this data cache stuff I will eventually want, but not right now, as I don't have the cache management instructions. I don't even have memory management yet. Also, let's make format things. And we don't need that anymore. don't have memory.h yet. Definitely don't have render.h. Cool. And integer size. Yeah, so I need to change the entire proxy structure because this is from a 32-bit machine. I'll be needing those. And make all the things 64-bit. Yeah, let's make the opcode 64-bit too. Actually, well, the opcode. Yeah, but then if it's 32 bits, it's not aligned, so that's just mildly annoying. Cool. And of course, assembler is broken. I probably messed up. Yeah, all these set 32 and write 32 things I'm not using yet, so I probably typoed something here. BIC. Yeah, I forgot an argument. So I ported this to ARM64. Well, I have serial enabled. They wouldn't be dumping things to serial if I didn't have serial enabled in the boot options, presumably. All right. Oh, by the way, speaking of ARM assembly, yeah, this is undocumented. This is really dumb. So when you do inline ARM assembly in GCC and in Clang, I think it might be documented in Clang. It's definitely not documented in GCC. You got these things called constraints, and normally this is how you specify what kind of register you want. But in ARM, all there is R for regular registers. But in ARM instructions, you can choose a 32-bit or a 64-bit type of register in the 64-bit ARM, which you can't on 32-bit ARM. How do you specify that? It's not documented. You need to use %W0, and percent just without the W is 64-bit. I mean, the register is, like W0, W1, whatever, but this is supposed to be a placeholder, right? So like using this modifier in the placeholder, it's completely undocumented. And the bug about documenting and improving that in GCC has been open since 2014. So yeah, that was fun. All right, what else did I break here? This is good. This is telling me all the typos I have in this code. Big one. Oh yeah, it needs to be. Oh, I probably have a one that that one. There we go. And now UART proxy. Start.h is probably just used for like. Oh wait, is it checksum? No, checksum's in here, isn't it? Yeah. What is start.h? Is it used for anything? Oh yeah, that's UART send buffer save. I changed the definitions of these. You're right. I think that came from like the USB gecko functions on the Wii way back. And then I need receive. The thing is, on x86, I think it's just in the constraints. You said the register type you want in the constraints or something, but or it uses on x86 it uses the size of the variable you pass as a register input, which makes sense. But on ARM, it just ignores that. And Clang actually throws a warning. Clang tells you if you have like a 32-bit variable and a 64-bit placeholder, at least. But GCC doesn't even do that, which is ridiculous. Okay. So it looks like macOS actually booted at least. And now the question is... Wait, hold on. It's probably once initial setup again. It's annoying. There's no reboot option. Yeah. And of course, Apple wants me to send them all the things. So let's turn that off as soon as I get through everything. Privacy. You can probably tell I'm using a track point. I have one, like a ThinkPad USB, track point embedded keyboard, which is very nice for messing around with things because it's very light and it does keyboard and mouse. Yeah, I think if you want to use the same register at multiple sizes on x86, you probably are SOL. I'm not sure, actually. Maybe there is some way of doing it. Yeah, so we have Mac OS. And yeah, the question now is this going to actually boot into my mini thing? So once this compiles, I'll do a test run. You want get char, yeah, let's get char. I keep forgetting. Yeah, it's actually should be get char, not get c. Just to be consistent with C. And it is put char, right? Yeah. Let's be consistent. Pretend to be, but actually I want put byte because it's because I have this new line hack in there for put char. Yes, that is a Glasgow. And it's also very noisy when it's not plugged in. Because I think it just gets nulls. But I wonder if I think that's actually probably... Hold on, let me see if I can put a resistor on it at least or something. That's better. Well, I still get the parity errors, but at least I don't get the like 50 hertz noise pickup. That's better anyway. Yeah, because it should be idling high, but of course when the power is dead. I should just shut this up, to be honest. Probably, yeah, just get rid of -v, maybe? Nah. Can I un-v it? Forget if there's a way of hiding warnings. There should be a Q or something. Yeah, there's a Q. That's what I want. Cool. Maybe. Or not. QQ. Yeah, that sounds about right. Okay, get byte, put char, get char. Well, actually, let's call it get byte. And we can do the same thing with get char and do some new line hackery. So let's call this... Let's do that. And we don't have UART right yet, but at least this should build. let's debug put. Yeah, well, that's fine, but I need that or not. All right, and go back to proxy. UART read. Well, that should just be. Yeah, sure. I'll make it return a size t. Even though this, I don't plan on doing a timeout on it, but I might. Cool. And then there's a check something. What's going on here? Request. Yeah, memory requests. Where is that reply? Time reply. It's over here. Cool. And those can be U32s. And do I want that to be aligned? Trying to see if I can. Also, since this is going through a UART, and like actually saving a few bytes for memory reads and writes does matter a lot for speed. Yeah, it's supposed to be 1.2 volts, but Glasgow only goes to 1.8, but it's close enough for receiving, and for transmitting, I'll just do a resistor divider. Like if you get like it's the same with 3.3 volts and 5 volts, right? Like you can use a 5 volt UART with a 3.3 volt transmitter, and then on the other direction just put a resistor or something, and like it's if it's close enough, the receive levels are good enough, and on transmit you can just do it the cheap way. I actually don't know if Glasgow can go lower. Like on paper, we support down to 1.8 volts, but I don't think like that's literally the lowest the DAC can go or something. So I should see how low we can actually do it. I don't know if this actually will it actually let me try to do less than 1.8 volts. It lets me do 1.7. Yeah. So apparently 1.7 is like within the range. 1.65. I don't actually know what the formula is, because this is of course like it's going to like a DAG into a reference pin on the regulator. Apparently 1.65. Well, cool. Okay, we're gonna call it 1.65. Where was I? Okay, type, address, size. I'm only really doing like a few types here, am I? Yeah. Oh, yeah, but I do have a magic number. I do want that, so that can be 32 bits. And the proxy request. You know what? If I make this 32 bits... Oh, but then the alignment is annoying. Oh, but I wonder if I can do a little cheat here. Nah, not worth it. So just to save another 4 bytes there, what I am going to do is... This can be 32 bits. The size doesn't... I'm definitely not going to be copying more than 64 gigs over this. Oh, that doesn't matter, because proxy request is larger anyway. And yeah, so I'm going to do a little cheat here. That should actually just work. Crystal type +1. Yeah, that should actually work. And then we just ignore the little path thing. Actually, do I even need this? This request thing doesn't even need to have the header for anything anyway. So, oh, but I have the checksum in there. Something like that. Okay, so going back to macOS here. What just happened there, by the way? Oh. I think it's... Okay, that was just when I shut it down. Yeah, this capture card likes to keep like the last frame, so it's confusing sometimes. You think it's up and it's not up when the feed dies. All right, so build again, UART read. So these are just steps. I just want to see if this still works. Read. Cool, okay. So if I get the logo like before, that means this works. If I don't, then that means this doesn't work. Not the laptop, the Mac Mini. Oh, this is going back into macOS now. I guess the update set that as default boot. I'm just going to kill it. And it panicked because I held down the button. That's hilarious. I think that's just because I held down the button, because otherwise it doesn't make a lot of sense. What's that panic? That is really funny. Debugger message panic. LLC bus error. Button reset. Yeah, I think I just crashed macOS by actually pressing the power button. That's really funny. And of course, nobody would notice that panic because it happens when you're hard shutting down the system anyway. That's great. Have I mentioned that the whole M1 macOS thing is clearly rushed and buggy to some extent? Like they of course they nailed the marketing because it's Apple, right? But then you look into all the little corners and everything, and there is so much subtly broken stuff that is getting fixed in the betas and in the like there was a day zero patch even. So yeah. That didn't sound nice. I think it's what I think it is. I think... Oh, yeah, it's boot looping before getting... Yeah, I think beta 2 broke booting beta 1. So now this doesn't work at all. Ha! Amazing. Because now this just happened on 2 machines. Well, yeah, PSA for anyone. So now I'm wondering if, because the OS is actually installed anyway, and I was experimenting with what we will eventually do is build our own macOS installer so we don't have to actually install true macOS anyway. So now I'm wondering if I can manually upgrade beta 1 to beta 2 on the quote-unquote Linux partition. I don't think this is downgrade prevention because I have disabled security with the tickets and everything, so it shouldn't actually care about any of that. But like maybe it's just not compatible. Like maybe they just don't promise, I guess, like, you know, interface compatibility. So maybe they just broke something, which is okay for betas, I guess. So what I want now is do my little I still haven't gotten SSH to work in recovery mode, by the way. I can make the user, and that works. And it will start SSH, but if you try to log in, you get a... Sorry, not log in. It gets a chroot error. It tries to chroot for the privilege separation, and that operation fails for some reason. But hey, I've got this. And yeah, so by the way, what this is doing is... where was that? That's what I called that. Yeah. So it pulls up a script binary, runs caffeine so it doesn't shut down on me, and then netcat script netcat, and then the actual shell is like this is that binary. So yeah, but it works great. You get a nice shell that actually has, you know, like completion and stuff. So let's see. Volumes. So it should be in pre-boot. The Linux pre-boot is 3, which is pre-boot. So this is the old OS. And in theory, -D, so it should be this. Yeah, so this is the Linux boot policy. And so in principle, this library stuff, this boot subdirectory has all the actual... Oh, wow, I just realized that all the old custom kernels I've been making stick around forever. I should probably clean that up. Let's just delete everything and we can make a new one later. Wait. Oh, yeah, that looks better. So that's just the macOS one, which is interesting. January 10. Is that when I don't remember why that has that date. I think that was probably when I reinstalled it. So, and yeah, so this whole firmware thing in here, right? I should make my thing set an actual PS1 that is useful. But anyway, actually, yes, do that. How'd you do this on Bash again? Is it -D or no? What was the PWD on Bash? I forget. Expanded below. Current directory W. That's long, but can you get the abbreviated version? Just the last component. Uppercase. Yeah, okay, for this one it's very annoying, but... Yeah, hostname isn't even useful, is it? Cool. Put this into my script here. Okay. So I don't know if actually there's any way of getting more information on this, but yeah, apticket.dir is probably it's just the ticket we need, and all the firmware stuff. So okay, so let's just do this. And I don't know if we need this restore stuff. We might. So what I'm going to do is make a back copy of this just to make sure. And then go in here and pre-boot one. And if I just copy boot, so that's the current, hold on. I need probably all of restore. And all of boot, but in the right hash, which is not this. Yes, let's do that. Yep, let's copy that to 7. Oh yeah, I changed my terminal width. I should fix that. Hold on. That's the problem. Is I. Oh. Yeah, that just broke there. Yeah. Exiting didn't quite work. Ooh. Yeah. That again. I should make that a loop. And now the wrapping should be good. Because it doesn't update the terminal width when I resize the SSH, like the terminal when, unlike SSH, which would do that because it has like a side channel. Let's reboot one, DC boot, BF whatever, user. Question is it's going to actually be faster than just reinstalling macOS? Okay, so let's copy that and then restore. I think this restore stuff isn't actually needed to boot, but I think it actually is needed to, like, for the boot picker to not hate me. So hopefully that will work. Yep. Okay, let's try that. And actually, I want this is going to be useful if it fails. Bootability. I don't think this actually created a boot policy, so this might not actually work. Because that probably needs to be regened anyway. Yeah, I don't think that worked. Wait, what is it doing now? Oh yeah, it went into recovery. Custom kernel fate to boot. That's fine. That probably just needs to get the boot policy recreated, which is okay. But I want to do that from 1TR, not from... This is going to be the regular recovery. I wonder if I can delete the boot policy and recreate it. Oh, but then the user thing is going to be messed up, isn't it? But we'll see. I mean, if this doesn't work, I'll just reinstall macOS, but it's annoying. Actually, what I want to do here is... sorry. I'm kind of worried. The thing is, if I completely wipe the boot policy, it might mess up the user stuff. Like if the user identity for this change, I don't know how the like authentication stuff is tied. All right, let's go back to this. By the way, this did get updated, right? Yeah, okay, so the 1TR is, of course, updated with this. So first of all, can I just recreate the whole policy, log everything, and then do nkcas? That should be, wait, 5.8, right? It was 5.8, yes. Verified, checking SFR version, authorizing for local policy transition, recreates, boot objects. I think this will, if it's going to work, this should work. That all looks reasonable. And then I need the kmutil thing. But let's just do my... Actually, I need to Control-C this anyway. There's no way they're doing NUMA. So, I mean, you mean like regular NUMA? You mean like on-chip and external RAM at the same time? Yeah, that could happen. All right. Yay, it works. Cool. Okay, we've proven that we can, in fact, update and fix macOS this way. and that indeed something broke about, and that's a previous version. I was trying to dump the device tree, and it's going to hit the watchdog timer. Oh no, that is this version. Sorry. I do have that in main, right? Yeah. That's this thing. It is going to die in a bit, because the watchdog's going to hit and bark. Real soon. Yep, there you go. Cool. Okay, so now I'm wondering if because I don't want to reinstall macOS on this MacBook Air. It's annoying. What do I do? Because I want to use the MacBook Air for experimenting with macOS, but I don't really feel like reinstalling and setting up SSH and everything again. So I wonder if I can do the same thing. And but then macOS, no, but it shouldn't care about the signed system volume because I turned that off. Let's stop this from looping. Well, since I'm not going to be using anything macOS yet, I will work on Mini first, and then if the time comes that I need macOS, I'll try to fix the MacBook Air. Yeah, let me just say that on IRC. Because people should know. All right, so UART proxy. So I need a UART read, and this is that Samsung thing. Let's see. The funny thing is, the first time I ever ported Linux to something, it was in fact a Samsung chip. So I remember there's some Chromium OS code that is really simple for this. Yeah, it is. Because the Linux driver for this is Linux has a driver for this. Yeah, this is what I need, basically. It's just checking that. UART base, UTR stat bit 1 is the receive, and then URXH. That's easy enough. And let's put these in a nicer order. Cool. And UART proxy.h, and let's just do that. UART proxy run. Let me just review this to make sure that I'm not doing anything dumb with like 32-bit versus 64-bit. Reply should be fine. This type. This all looks semi-reasonable. Checksum is at the end. Checksum is at the end of this. Yeah, this will probably work. We build, yes we do. And I need to actually connect to the receive line. So give me 1 second to find some resistors. 1.6 volts, 1.2 volts. That's what, 2/3 or something like that? That should work, right? Yeah, a bit more than that. Yeah, like 330, 220, but actually let's do 1K and... yeah, that'll work. 470 ohm and 1K or so resistors. Okay, I'll be right back. Okay, let me plug this in. That should be done. And actually, before I run the proxy, I'm going to do something a bit more obvious. This works, then, you know. Oh, hold on. Are we there? Helps if I turn it on. Helps if I'm stupid. Whoops. Is there a hotkey to get to the terminal here to focus it? That'd be nice. Probably not. Oh, there is. Excellent. Focus terminal, Control Shift F4. That's a terrible hotkey. Let's do something more useful. Yeah, that's better. Hey! Input works. Cool, okay. And just to make sure that in Proxy I do indeed have some in the... Yeah, I have call func. So, you know, on paper, I should be able to chain load stuff in a really dumb way by just putting it in memory, jumping to it, and passing the same boot arg structure. And I think the way I'm doing this right now is I don't care about the physical base, because I reference the... Yeah, I reference the boot args via... yeah, that's just... and that's just static, and then like the def tree and stuff is so like I don't care if this is not correct because I get my own base, which means that in principle doing this the dumb way I should be able to chain load by just passing boot args, which means all I need is a function to get boot args. So let's add that right now. Because that way, if this build works, then I literally will never have to go into recovery mode ever again. Until I want to make it persistent. If I make a significant improvement, I can just chain load if I need to add features. Oh, Project Zero had... She has just mentioned on IRC that Project Zero has a code to disable the watchdog. Well, we're going to find out if that works real soon now, because if this works, I'll have a register pokes. All right. Proxy.h, get boot args, proxy.c, get boot args. And it should just be... Actually, you know what? I need read 64 and write 64, don't I? Because this is a 64-bit machine indeed. We are going to break binary compat. was thinking I might not need those, but I definitely will at some point. So let's take care of it now. Do I need mem copy 64? Let's be consistent and do mem copy 64. And these aren't implemented yet, but that's fine. And then I need the utils. See, this is very me, like, you know, okay, I know this works, so instead of doing like 5 more test cycles, let's just YOLO it. And if I get lucky, then it's a bunch of time saved. Actually, you know what? That should work. And then proxy, get boot args. Red val was indeed 64 bits. Yes, it is. 364. Not really 64, so this is just going to be like... but I want the original boot arg structure, not the current boot arg, so I actually should save that somewhere. So I'm making a copy in case I overwrite that, but for now... This is called boot args address. That can't be avoided. Yeah, it's I like parameters to be like integers, not pointers. It's a bit of a style thing, but you know, like what's like using pointers or things you make in C, and using integers for things that are passed around as part of an ABI. It's a bit of a wash which convention you use, but that's usually how I like to do it. I should have a startup that's aged here, shouldn't I? Because I will probably end up having a function to boot kernels in there. Not even startup age, sorry. GNU boot. It should be in GNU boot. Sorry, yeah, it should be in GNU boot. Sorry, that's dumb. Okay, that can be in GNU boot, and then in proxy. Oh, sorry, not here. Proxy C. That seems like it might work. And then in principle, if I just put a new mini somewhere in RAM, get boot args, pass that as the first argument to pcall, and jump to the entry point, which I think it's always plus... I think it's always like... Yeah, 8,000 into the file. It should be the start of the text section. Because the header is at... No, header's at... Oh, init, sorry, yeah. 8,000 ties init, which is where the entry point is. So for now, that's... I don't have to parse the file. Cool. Dean asks if Apple added the kernel loading support in reaction to my efforts. No, this was definitely like planned all along. Like it's a lot of code that's been developed. It's just that for some reason, it was like originally there was evidence that it was going to be released, and then it ended up in the man page, and then it ended up in the actual binary. So like for some reason the whole thing was delayed, but like as I said, the whole M1 launch was clearly rushed. So this was not some kind of fast Apple reaction to what I'm working on. This was just them lagging behind their intentions when the M1 was originally released. But I also avoided like talking a lot about this fact because if I had like from the very beginning being prefixing all my announcements with disclaimer, this doesn't actually work yet and Apple doesn't let us do this yet, I would have had hundreds of people saying, oh, Apple is never going to actually implement this and all that stuff, when it was clear from a technical standpoint that they were in fact going to implement this and make it all work. But like I know that because I've seen the man pages and the amount of effort that they put into this, but it is very easy to say, oh, why do you think Apple is ever going to release that? It's like, no, it was really obvious they were going to release it. Cool. And now the 64-bit calls. That should work. Oh, I don't have the mem copies yet. That's true. Need to do that. That's gonna not link now. Yep. These should be size T's, but whatever. Let's fix that. Honestly, this should be size T too. This hex dump routine, even though reformatted, has been copied around since the very early days of Wii stuff. Like I wrote this at some point, and it's ended up in a lot of very random places, and other people have copied and pasted it. I think that works. Yeah, something like that. Ooh. Am I missing the... No? What did I do? Oh, it's... No? Oh, do I not have size T and types? Invalid storage class? What did it just... this is something dumb. Something just very stupid just happened. Oh, yeah, duh. I haven't updated these. I was missing some stuff there. Or not. Oh, okay. That's why. Yeah, that looked like a missing brace somewhere. I'm like, what? And cool. Let's see if that works. I should put a printf in here. Can do that for the next loop. Audio feedback delay? What audio feedback delay? Is the audio weird? I don't think I have anything weird in the chain here. Oh, that's going out. The pings are going out through that. Yeah, that's not supposed to happen. Yeah, because that's hopefully that doesn't happen anymore. Cool. All right. So time for the other side. You know what? Just because I added the printf and I want that printf, I'm just going to reboot it and let it reload while I do the rest of the work. Because this is where it gets fun. Because I keep typing mini instead of m1n1. It'll take a while to get used to that. Also, we can probably commit this so far. Have some semblance of useful history. Oh, hold on. Not the proxy client. There should be a lot of random crap here that I definitely don't need. Like, this is probably a Wii U boot ROM or something. Or maybe it's the SVMP boot ROM, I don't remember. It's probably the SVMP boot ROM. I think we were looking at that for some reason. And that's probably the SVMP firmware. Definitely don't need any of that. So much random crap in here. Also all the backup files. Also, this is probably Python 2, so that's going to need an upgrade. I don't need a bunny or a git ignore or LCD test functions. What's power on? Don't need that. What's USB test? Oh, this was messing with the, oh, this might actually be useful. Yeah, this is testing the USB hardware and the SBMP. And I might be able to reuse some of that because I will indeed test the USB hardware on the M1 eventually. That's another thing I will be developing. So some people asking about text size. I'm trying to keep the fonts a bit larger than I normally would when I stream, but so I want army tools. What's sniffer? That's one of those, right? Yeah. This is useful. This is that thing that looks for register changes. And what's this one? It's running it's only register changes, but I can combine it with a shell. Okay, let's open everything and see what's useful in here. That's how you port things, right? What device is this? This is a Glasgow, so actually it needs to be like not TTY, but like what I want to run is PTY because this is serial. Will PySerial work on this? I hope so. We'll see if PySerial likes a PTY instead of a serial. Also, this is all tabs. Yeah, hopefully that works. Yeah, those alignment arrows, huh? I should not copy and paste. All right. Let's see. Let's call these the same way. Remember, this is very old code, so my coding style has in fact changed. This is annoying now, so I have everything to then. There's probably like a nicer way of doing enums in Python these days, but mouse cursor. Definitely don't need these. And this is kind of dumb, so it's just an eyesore on the code, so I'm just gonna do that for now. By the way, can you hear the Mac booting? I guess you can when I'm talking, probably the dong, but it might be too quiet. Like every time it reboots, it does the bong. Like right there. I guess it doesn't trigger the gate, it's too quiet. All right. Yeah, when I'm typing, right? So, checksum should be the same. Reads. What was the dem? The size is going to be different now, isn't it? Should have used the compute size thing for that. Also, this is all Python 2, so this is going to have to be fixed. And rewriting a lot of this, am I not? Horrible Python 2 code. Should have just actually, let me just 2-3 this real quick. I do inline. I guess the prints are done now. Okay, so yeah. Welcome to fixing old horrible code stream. Command, payload. This packing 28 payload size. Yep. So what do we have here? Proxy request and proxy player, probably the largest ones. It's 7. Yeah, 7 words for proxy request. That's actually going to be the biggest waste of serial bandwidth here. But maybe that's just motivation to redo this in. You know, I should have just done this as 32-bit arguments and then like combined them. But nah, whatever. This is all going to go through USB eventually. If it gets too slow, I will add hacks to make it faster. So we have 7 words there. And that adds, yeah, it's 1 type and 1 checksum after that. So that's fine. So it should be 364 bytes. Why is it more than double what it used to be? That doesn't make sense. It was 28. 32 plus like 7 words. It should be 9 words, yeah? Oh, wait, sorry, that's minus the, yeah, it's minus the header, right? So, yeah, it'd be 32. Yeah, that makes sense. No, it doesn't make sense. Oh, it doesn't include the checksum, probably. Yeah, that's why. Yeah, that makes sense. Okay. So it's 56 for the actual command portion. Oh, you're right. No, it's not the order. It's the... Yeah, it's the order. Thanks. Someone pointed that one out. This worked, right? Isn't there an RPad on that? Or just... I'll just... Yeah, that's what I want. Python 3 makes life easier. And then we get command plus payload. The command does that. The payload should be whatever that is. And then the checksum is 32 bits too. That's fine. We can debug. And then the right unknown handler, TTY. Yep, that's all the... All that stuff is going to be useful. Check for the... That's 21. Why is it 21? Where did 21 come from? Oh, that's the reply, sorry. It's not command line then. That makes more sense. The reply should be type status, a proxy reply, and the checksum. The proxy reply is 3 words. So it should be 4 times 8. 34, 36 minus that should be... That's supposed to be payload line, but whatever. And it's an integer, and the status... Why is that U32? It should be S32, shouldn't it? Yeah, actually, that's the bug. Still works though, but that looks good. That's fine. Address nice checksum. It was Q, wasn't it? Yeah. Checksum, that should be fine. Again, just blindly coding here, not testing anything, but let's see if this works doing it here. So we got the reply, and then we got proxy rec, and yeah, this as long as no data sizes or numbers are in there, might be good. 6 arguments, struct pack. Let's just call that 6Q. Thank you very much. It should really be 16, but then it makes everything too wide. And most of the time it's going to be 32 bits, so I'm okay with that being slightly inconsistent. ROP status red. The proxy reply is what? It's all, yeah, it's all queues. And we want get boot args in here. That all looks reasonable. And this, oh yeah, I guess, yeah, fine. Oh, there's one more thing I should get. I should add an operation for get base. Yeah, the memory allocation thing is going to be annoying, but that's okay. For now, we can experiment with this. I can do one, yeah, as long as like I load something and know where the stuff is on the boot args, I can, yeah, I can bullshit this for now. Because eventually what I want to do is have an actual call for booting a, how do you pronounce, like, is it mach or mach, or like, I've never thought about that. Like, mach object or match object or macho, like how do you call those things? But anyway, yeah, booting another binary properly and doing it, like replacing itself in memory instead of putting it somewhere else. But for now, this will work. All right, is that going to work? Mac? Is it Mac? Okay, so Mako then for wait. I need more debug on this, don't I? Where did it go anyway? It just reads one. Oh, there's no timeouts because this is a PTY. It's not a serial port. Yeah. Probably. Well, for now, let's try that. Why is payload a string? Ah, because there's quotes in there. Why is that even a thing? Should just be the default. And of course, there's no OR. The checksum function is, yeah. That should just be that. Where is I'm using ORD? ASCII. Also, this code is just ugly. Oh, so why is pad a thing? That's already a function. This is another Python function that has come like through the ages for forever. I guess, and then quotes, it's not pad, it's would just be hex dump dot. to adjust or fill? What was that thing again? Just. And I can probably just do it in the format string anyway, but... Okay, we're getting somewhere. Maybe. And I get the feeling this might not actually be working with the PTY. So it's writing to... It's definitely writing something. You know what? I shouldn't be using a TTY, probably. Well, it depends. All right, how do we do like this? I probably want to add some printfs here, even though that's going to break the protocol. Not necessarily going to break the protocol, actually. Just at least get the headers down. Oh, no, yeah, it would help if I implemented this, wouldn't it? That would be helpful. Next test cycle. I'll leave those in just to prove that it works. It just adds spam, but it will, in principle, still work. Yep. That is not going to be a const. Let's see. Come on. It's kind of annoying how long it takes to build a boot policy and then reboot. Okay, we got something. The TTY, we got some feedback at least. Proxy. And yeah, these are hey, something happened. Cool. So it got that at least. 5555AA 00. And then it times out. So the timeouts work, so that's good. So wait, if the timeouts work, why? Oh. Oh. Oh, I see. Okay, so the timeout on serial by default, there's like nothing in it. Yeah, okay, that's why. So in principle, if I do... So it's nice. This does work then with the TTY. Let's do it like this then. Or not. Oh, so it doesn't work. Huh? Oh. Hmm? Wait, so it was timing out. Oh, it's just like, okay, maybe timeouts don't work, but like partial reads do or something. Well, okay, I'll figure that out later. But for now, let's just comment that out. So the timeout works. It's probably one of those things where if you try to read and there's nothing in the buffer, it'll still block or... Eh. Okay, so 5500 does work. And what else is broken now? Goes 0, puts that up, that's fine. Then it hopefully reads more stuff. Wait, hold on. Yeah, that's fine. UART request, -4. Yeah, continue. And then the checksum. Oh, hold on. That's not right. Or is it? No, it's fine. No, it's -8 because of the padding. That's why. That makes more sense. Well, let me get more prints here anyway. Try to break while that runs. And back. And give me 1 second. I need to make a Hacker News comment because apparently last night's thing made it to Hacker News, and someone said it's an Intel Mac, which it isn't. So might as well spam the stream on Hacker News, right? Okay. So, is this going to work? Nope. Oh, wait, no, it's rebooting right now. Bad timing. Not quite. Length is okay, and then checksum failed, I think. Yeah, that sounds about right. But that also looks like it's not... Oh, yeah, I'm not sending enough bytes, because otherwise it wouldn't be hanging there. Let's see. Size of request -8. That should be... Let me just do a bit of math. I knew I was going to get some of the lengths wrong. Okay, so it's 7 times 8 bytes for the 56 for the request, plus 4 bytes plus 4 bytes. So it should be 64 bytes for everything. And the length of that should be that plus 4, but we already read 4 bytes. So it should be -8. So that should be right. So we should be writing 64 bytes. Are we writing 64 bytes? It is 64 bytes. Huh. Where's my bug? We did get 64 here. 40. Wait, no, that's not right. That's not right. Why is that? Oh, because it pads. Because it pads. That's why. Yeah. Okay. Let me just. Yeah, I'm cheating with this stupid thing. This is dumb, but yeah. Minus the checksum, so it should be -4. So rewrite 4 bytes. And then the checksum should be rect size -8. No, -4. No, -4, because we did get that in there. This is so ugly. It's to save 4 bytes. It's probably a dumb idea anyway, but yeah, that might work. And for the reply, it should actually be saying, because I'm doing anything weird to the reply, because I'll type status. Yeah, sure, okay. You have 290 people watching? Holy crap. Thanks, Shiz. I guess this pane is kind of useless now, isn't it? It'd be nice if it would like tee out the debug messages only, but it's not happening, is it? So many people commenting on Kate, like it's a text editor. I don't know. It's why are text editors always like such a point of discussion everywhere? I don't know. I mean, it's like Kate does what I need and doesn't try to do too much. I could probably try using Kdevelop and at least get like clickable build line numbers, but honestly, it's not that big a deal. And other than that, it's like it's a convenient editor. I don't know. It's not quite there yet. 3C. Is that correct? It should be reading 7 times 8 plus 4. No. Yeah, that's correct. Well, am I not sending 3C? Wait. It should be sending 40, right? Yeah, I am. Why is that now not working? That is quite interesting. Kate is not the default KDE text editor. That would be kwrite. But kwrite is like Notepad, and Kate is, I guess, like Notepad++. Like, Kate is a perfectly fine coding text editor. It's not trying to be an IDE, and it's not, Notepad. It's just right. I mean, I use Nano, and Nano's the only thing that's installed, and I could use it fine. I mean, I'm a very simplistic Vim user. Like, I use Vim as if it were Nano plus a couple features that I actually remember when I'm on servers and stuff. So I prefer it to Nano, but for only like 1% of the things that it offers over Nano. So what am I doing wrong here? Are the bytes not actually getting here? Well, coming with Nano and not Vim makes sense just because it's smaller, right? So it's a least common denominator, and then you just install whatever you want, because some people are going to want Emacs. mean, who cares what editor comes pre-installed as long as something you can use to edit a couple of files comes pre-installed, and you just install whatever you need. And you need Nano anywhere because you shouldn't expect every user to know Vim or every user to know Emacs or every user to know anything, and Nano is accessible to everyone. Like, Nano as a default editor choice makes perfect sense for a distro, I mean. Now, what does annoy me is when people build, like, you know, an embedded system with BusyBox and don't build, like, the VI applet. And then it's really annoying because you can't just put it in. So if you build BusyBox, for fuck's sake, put VI in it. Like, not including editors like that is fine when you can just install them. When you can't, it's really annoying. Okay. Something is clearly wrong here. That is not right. Oh, right now the buffer is probably getting filled up. Oh, I know what's going on. I broke this. Yeah, okay, I know what's good. My debug prints are breaking everything. Because the buffer is too small. This is not... Yeah, that's why, right? This fills the buffer while it tries to print synchronously. Remove debug and fix this everything, I bet. Using Electron is fine, as long as it's a choice you make. I mean, honestly, it's just... Like, you can get so much stuff done with Electron, but holy crap, the memory usage. But I think it's also like a culture thing, right? Like I see Discord sometimes eating 100% CPU, and I have no idea why. Now, clearly there's no excuse for that, while I'm maybe only doing audio, like voice chat or something, but it's like nobody debugs those things with Electron apps because people just expect them to be stupidly heavy to ridiculous extents. UART get jar is right now not used, but good point that it should actually do something. Though I don't know if I'm ever going to actually use that. It's intended for text. If I had like a shell or something, but and actually that should be probably an int or something, but whatever. All right, is this going to work? Yay! Reply checksum error, but there is a reply, so now probably my Python checksum code is broken. Cool. Fix that. Let's see, 936. And clearly I have a length problem in there somewhere anyway. Let's see. At least the size is definitely correct, because we got it to the checksum. We got there. Oh, and this should actually be an exception, not CRC. CRC is not a checksum. This isn't even a checksum. It's actually a thing. It's a thing I made up. I don't know if it's any good, but it's some kind of checksum. This is Gen 2 Linux. I don't need to build anything. So actually, let me start running this here. Is it rebooting now? No. Huh. Oh, I guess at the. So checksum error. Why? Probably because of something. The checksum in this direction worked fine, because otherwise it would have not replied. So the code is fine. That's interesting. Wait, hold on. It's rebooting now, but wait, why is it dead now? Oh, huh? Oh, forgot this. Hitting the wrong device. Am I calculating it wrong here? That's more likely. Type status. Same thing. It's gonna get padded. That's why. Because it's unaligned at the end. Wait, I should actually just... How did you do the pact on this? Do I have it in utils? Or in types? No, but... I always forget where it goes. Does it go like after the struct? I think so. Or not. Is that actually going to work? Yeah. So you actually get interesting. You get a warning when you do that. P request. It's not going to be an unaligned pointer value, but it complains that it might be. Fine. Undo. That was 8 times 436, was it? Yeah. Then it also adds zeros at the end, which I don't want. Well, that's fine. The vents, that's fine. Honestly, I'm not even terribly happy with the protocol right now. Like, it really should have variable length arguments to avoid all the overhead. Because the thing is, the reason why this is like using fixed fields is because this was originally an in-memory protocol, which was a ring buffer of fixed size commands between two CPUs, and then it got shoehorned into this UART thing. And so it's not the best protocol. So if later on I find that I'm wasting too much time, then I might just redo the protocol design, like keeping the downstream command, keeping the proxy part the same. I will redo the UART part with variable length arguments, like variable length requests. I actually need a drink. Let me see if there's some tea upstairs or something. Oh, there was some tea right here. Hey, got somewhere. So the proxy's broken, the knob works. Let's see. Ah. Hey! And it works. Excellent. All right, now we're going to start having fun. So I can do this. Will this work? Yep, and I can do reads and writes and things. Now it's rebooting. Yeah, and you get the text speed when it initializes, which is helpful. Cool. So I guess this is worth a commit. This is definitely not correct for this device anyway. And I should probably add some like initialization useful stuff in here. So let's see. Yeah, it should have a thing for getting base on the proxy. Let's add that. And that should be relocated. So in principle, oh, by the way, you haven't seen this. This is my amazing linker script that makes a Mako file in the linker script. So I don't need a Mako toolchain. I can use an elf toolchain. And yeah, this should actually be relocatable. So And this is, by the way, the quote-unquote clean way of accessing linker addresses from code. Because the address represents a variable that is at that. So if you declare it as a char or something array, the length doesn't matter. Then the array is at that address, so that's how you get the number off of the linker script. And the relocations should process that, so that even though it's 0, it's not going to be 0 by the time it gets here. Is the screen like blinking a different like color temperature and then coming back to? I'm not watching the capture card, but I assume it's doing that. It's be around this time of the day that that is switching, right? I guess. I should somehow. This is Gen 2. I can in fact just patch KDEs and like not do that on like if it's a cloned monitor or something. I should just look at the code and fix that, but not now. That would be a very, very deep jack shave. All right. There we go. Yep, so now we got some variables going. So let's try writing a script to load another version of Mini. I should implement some of this structure in here. And I will use construct for this because I like construct. And I already did a Mako thing. If I do this, actually, it's easier this way. Kernel tests Maho dump. So I will in fact need some of these later anyway. Oh no, because I will implement loading it properly in the file. But I can just copy and paste these things. And actually, I want some license info here. So let's do, well, I don't need the video, but I guess I'll do it anyway. I wish there was some like automated conversion tool for this. Can't do that. And also this hex thing, I should I honestly should just monkey patch that because it's going to follow me forever. But I don't always want hex. Nah, whatever. And I guess this is nice formatted like this. Get this tab aligned. Should fix my editor config to do that automatically too, but I bet someone's written a tool to convert C structs to construct. Confusing myself with block mode. And command line should be padded string. How is that thing done? Yeah, just like that. What's the boot arg size? That should work. If I got that right. And now in principle, I can actually just make I just read that actually, but can I make a convenience function here? Yeah, probably. Why is there a race that isn't a race anymore? I think that's some weird test I was doing that. Let's see. That does work, right? Yeah. Not types. Oh, is types already? Yeah, types is already a Python thing, isn't it? Should just doing it here, but It's not even always types. It's, what am I going to call this? m1n1 types is too annoying to type. Other types, target types. TG types, that'll work. Should have just done this again, but okay. Yeah, and I should avoid importing golf construct, but I can do that later. Yeah, that does work. And now in principle, I can just do BA address and BA equals. Well, this is redundant, but for the no, it isn't redundant, sorry. And also armutils is probably, oh yeah, this is all ARM32 crap. I should fix that later. And also this is no, I have a better way of doing this now. I have an assembly thing I will insert here later. But for now, it's struct, read struct. No, oh, sorry, yeah, it's because it's not get struct. It's iFace or not. What did I call it? Read struct. Of course, it's rebooting. I'm getting garbage in the boot args. Probably. Wait. This is going to get padded, isn't it? Yeah, this is definitely going to get padded. Those are aligned, those are aligned. That's not aligned. Okay. Hey, that works. There's some print or just print VA. Yeah, cool. Mem size actually 0? I thought... Didn't I get that? No, it's... That's not right. Something went wrong. Is the command line length wrong, so I'm missing data at the end, or... Oh, more padding, I bet. That's padded, and then command line shouldn't be padded, but the next thing will be. Yeah. Yep, that looks good. See, when you're doing things with a very explicit structure library like this, you see all the magic padding that the compiler inserts that you never think about when you're working in C with size of and all that. All right, so let's see. So let's see if I can do a very dumb chain load. In principle, everything after top of kernel data should be free for me to do whatever. Also, it's interesting. That's after, where is that? 803 C3. That's pretty high. I guess the device tree is pretty big. Yeah. So if I load stuff after that, it should be good for chain loading. So let's see if that works. That's another fun file. This is a malloc implementation in Python, as in with the heap structures in Python. So I can allocate addresses on the target. This is like the SPM PLCD stuff. But anyway, let's see. It's a simple thing I can do on this. Yeah, just copy and paste this. Let's align this a little bit. Hard coding it, but I know that's correct for the current code. That will change later. And in principle, if I do that, and I can just do a very quick, and then do iface.nop. Was it nop? Yeah, it's just NOP. And also, I should put this in the shell. Just to prove that everything works. Is it restruct? I always forget what I call that damn function. It is restruct, hold on. It's not iFace, it's it is iFace. And then I need a it's a proxy, yeah. Mm-hmm. Oh, hold on. Oh, that's gonna be too big, isn't it? Yeah, it's gonna be too big to actually load. Because I have all that junk of all that padding. It's gonna reboot before I can actually chain load anything. Yeah, that's the problem. Is all of this, like, I have all of this hideous alignment, and I think I don't know what the minimum alignment is. I know that it hates me when if I don't align the sections enough, but I'm not sure if it's like 4K pages or if only the whole file needs to be aligned, or so it might be worth doing a little bit of checking. Like, I think 16K alignment should be enough, so it definitely should be happy with like this should definitely work. And we'll probably cut down like my total size by half. Or not. Hold on, is a stack getting included there? Oh, it's actually quite a bit of code. What is that? Oh, that's the logo. Oh, I got the logos. Yeah, the logos are big, aren't they? Okay, let's temporarily not do the logo thing. As nice as that is. It's still big. Is it not doing like section removal? Like if function sections or whatever. That's another thing that is useful. I want this to remove files and data that I don't need. Huh? Oh, that's not right. Why is this hiding? Katie, what are you doing? I know I updated Katie recently, and I think it just decided to hide dot files, which is like, nope, 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 nope. Oh, come on. Here? Yeah, okay, thank you. Tab width, that's what I need here. Yeah, it's better. Make files need tabs and... Nope. Yeah, so why is that included if it's not? Yeah, it is using it for function sections. Wait. Yeah, it's just the inside. I don't have keep or anything in there. How do I get it to do that? GC sections probably. Yeah. Still has a bunch of crap in there though. Why is it there? Yeah, I'm good with those, but why only those? Shouldn't be used anywhere. Like linker scripts and linkers are always this weird voodoo. Bigger page. All sections containing symbols referenced by dynamic objects. So you think it's like, this is a dynamic executable. It has relocations. I wonder if that's related to it. Like if there are relocations left, then it doesn't GC them. Which is really annoying if that's what it's doing. Wait, that's interesting actually. Is it doing a like No, but Rela also uses a function sections, so in theory they should go away together. And Rela here is also not like using keep or anything, is it? No. Just out of curiosity. Actually, if I just discard that just as a test. No, that's also not helping. What is that, actually? Oh, if data sections is probably also helpful. Still not what I want. That sounds like a useful post. The best and worst. I wonder what the worst are. No. Let's relax. Machine-dependent effects. I wonder if that's... Actually, you know what? Is that related? Ah! So is that what it is? Is that going to break everything, though? That looks reasonable. Is removing useless stuff. Are the relocations still there? Though I have no pi here and like pi here, so I wonder like how dumb that is. But is there a pick? Well, it's kind of the same thing. The PIC versus PIA thing is always so confusing, especially since I'm doing like this weird relocatable embedded thing. Well, whatever. Let's see if it works. If I look at it has relocations. Also, the padding. Oh, that's just... hold on. Yeah, that's fine, because I have the N symbol there. Yeah, and also this should definitely be 4K. Now it's smaller. I have a chance at actually loading that. And on top of that, I don't actually care about the Mako header, so... And that is, in fact, going to be at 4 now. But I can also just do this. Save another 16K there. That's more sensible, yeah. And then what is it padded at the end to... Yeah, because that needed... that's why. But so the other thing I eventually want to do is actually just have a decompression implemented here. I'll put in some zlib or something. Let's see if this works. So the dumb thing is now I'm going to use like Pico comp on Glasgow. I should just put this in here, actually. Actually, I don't need to flash it. Why am I even doing this? I don't need to flash it. The thing that's in Flash is fine. It's just the thing I'm chain loading. Yeah. Still get the feeling this is going to time out. Oh, hey, it worked. It got to running proxy at least. Also, I did that wrong. See, this is the nice thing about relocatable executables, right? Like, once your code is literally put it anywhere in RAM and jump to it, it's very hard to mess that up. So then that broke after running proxy. Expected 1 bytes got 0 bytes. Why? I think it's rebooting. Or not. Yeah, it is. That's interesting. Why is it timing out? Am I doing it too quickly? I don't think so. Wait. Hold on. Something isn't right there. Oh, okay. Call is trying. That's why. Yeah, call is waiting for a reply, but there's no reply because it's a chain load. That's why. This is just call, but like no reply. I need a hack in here to not care about replies. What I really should do, actually, is just make the proxy code send a reply on the way back. Can I do that? Did I have any tags? No, I didn't have any tags. Yeah, that's going to be useful for chain loading, so let's do that. Let's implement that. And since I am flashing this, I'm going to get. I want the logo. Let's leave the logo in there for that. It's not really an error, but it's a proxy reboot. And then how do I want to do? I'm going to get the reboot on there. I should just ignore it or return. Actually, no, that's not what I want because the reboot's fine. But I should just get a... do it like this. And then in reply, and then if I get the boot reply, just to try again. That's for when I'm like in a shell and the thing reboots in the background, and then I send the command afterwards, and that way it won't get too confused. All right. This is a Philco Majest Touch something like Japanese layout, full size, with Cherry MX brown keys. My keyboard. These are brown, not red. Most of the clickiness you're hearing is just the keys bottoming out, not the actual, like if I type lightly, it's pretty quiet. But it's just, you know, hitting the base, the bottom out point is what makes it noisy. But it's noisier on the microphone than in real life. Also, I don't need that debug anymore. Let's do some git commits and clean this up. Well, first let's see if that works with the alignment. Definitely should work at that size. Hope I didn't break anything. Yes, it should be using 16K page sizes, I believe. Yeah, it works. And now let's see if my boot thing works. Blech. Typo. And now it reboots, of course. Also. Get boot args? Wait, hold on, wait. Not post request, this is just request. Boot true, and then I want this to use vector. Not that. Probably gonna time out now. Oh yeah, the logo. That's the way it makes cycle. Hey, getting somewhere. Got to running proxy, reply opcode error. Oh yeah, that shouldn't. Yeah, but that's not going to work because it's just the boot. So because there's no proxy reply here. If reboot, then don't care about whatever comes back from proxy rec. There's honestly no red val here to be had, so. Hey, it works. Cool. Okay, so we can chain load and keep running stuff, and I don't need to sleep anymore because that's actually going to wait for the reply. I should have a progress bar for right men, to be honest. And I think it just rebooted or something. I actually don't know how much buffering is going to go on here. Is it going to go in? There's it. It does actually block. Yeah, cool. Okay, so I can probably do that, like... What was the end thing there? Let's see. Is it rebooting? I was going to take the timeout. Yeah, it's annoying. That's an annoying. I guess print doesn't do. Yeah, you're right. Still not flushing. Oh, it's probably, yeah, the Glasgow probably writes in blocks or something. So there's too much buffering on the... There's probably too much buffering going on in the pipeline, so there's some feedback, but not enough. Sounds like that'll be close enough. I prefer my progress bars a little bit more granular, but it's better than nothing. Cool, that works. No, it should be fine, because this is the offset where it writes from, right? So if like the last block of data will still begin in, you know, like it should be fine. Like if it's 4 by 4, right, and it's 3 bytes, then it's 0 and then nothing. If it's 4, then it's still 0, nothing. If it's 5, it'll be 0 and 4, and then yeah, it should be fine. Not missing any blocks, I think. We'll find out if it breaks later. Cool. All right, so next thing, the stupid watchdog timer. I think this is actually the same in the Project Zero thing. I think they use the same addresses, so 1, 0. And then what this does to kill it is write 0 to C and write 0 to 1C. Well, those are already 0, so that's not good. And I do think this is the same address. Let me check the... device tree... 3D2B. Oh, it is wrong. 3D2B. Okay, that's interesting. What just broke there? Type bytes object. Oh, that's annoying. Whatever broke there. Huh. Because I'm in a shell, so it doesn't print full tracebacks. Hold on. Well, we'll find out next time, probably. Okay, that is 4, and that is... Oh, also, I definitely want history here. Can I do that? Oh, file name. No, that's just the current file name. That's not the history. Because Python learned to... Yeah, it learned to get history, and Python 2 used to not have that. So hopefully this supports it too. Does this derive from anything interesting? Nah. Oh. I do want my history. I mean, I could RL wrap it, but there's probably someone who's built a better solution for this. That's not what I want. That's something my boss said. It's something my boss wrote on the wall, actually, at an old job. Extend within, yeah, something like that. And no answers. Yay, Stack Overflow. There's going to be some way of doing that. Yes. Wow, that? All right, so can I get... Not doc. Can I just poke into the internals of this? Also, the Mac Mini isn't bonging anymore, and I wonder why. Oh, yeah, that. What was the print for that? Just print exception, to be honest. It's a bit more useful. Yeah, that's more like it. And now... So yes, I'm shaving yaks, but again, I'm going to be using this enough that this is going to be a useful tool. So wait, where is this thing doing? Is this doing raw input? Push... Oh. Oh. Jix says there's a history console at the end. Ah! Thank you. Yes, this is what I want. Does this need an exit? Yeah. Code OS read line. Yeah, that's cool. And just stick that in here too to avoid having a double subclass. Reboot. Come on. Where'd that go? Now that I saw that error. Return reply CMD. Oh, Proxy reply line 136. Yeah, that. Duh. That's what I want. Yeah, cool, that works. Console histories. Let's make that a nice file. Cool, that works. And then I just want, if I get tab completion, that'll be perfect. And I believe that can be done with the function I saw earlier. Huh? Yeah, so I want, that was in here, RL completer. Aha, just importing it should work. Oh, now I get no tab completion. Oh, but okay, yeah, sure. So, yeah, cool. Okay, that works. Excellent. Okay, since people are talking about the boot, actually, let me do a little quick overview of what's going on here, because I think I haven't actually explained any of this other than in IRC and stuff. So let me do a little quick demonstration of what's going on here. So when you boot the Mac, full screen it, and you hold down the power button, you go into the one true recovery, which is the sort of safe environment that is outside of any OSs on the system that gets updated when macOS gets updated, but it basically only goes forward, right? So if you wipe all of this, then you will have to update and fix the install through DFU mode, which is where you plug it in via a USB cable to another Mac and then run a tool they have to fix it. And we will make that work on Linux too eventually with the Linux host. But anyway, this is actually already macOS. It doesn't look like macOS. This is literally just a macOS program, and you can tell because when I go into options, the menu bar flashes boot picker. So this is literally like all keyboard and mouse interactions, and then those glitches are my capture card. All keyboard mouse interactions are already inside macOS. So this is a recovery macOS environment, and it's one to recovery. And then you can pick the OS to boot once and that first menu, or go into this thing where you can like run a few utilities and stuff like that, and change the startup disk, and it'll scan. And so what I have here is two quote-unquote macOS installs, but I'm replacing the kernel on the one called Linux. So like this is how booting on these machines works. Like the whole thing assumes that this is macOS and it has to look like macOS. So you need an APFS partition with multiple subvolumes and some plits that claim to be macOS. And like I tried changing this macOS text here and couldn't. You can change the version though. So this is how it's going to look for dual booting, and this should work just fine. And so let me close this to show you. So what actually went on here is that if you open up disk utility, I actually need to hit continue. That's annoying. So you can see what's going on here is I repartitioned the disk And to go to view, show all devices. And so this is what it looks like, right? So there's macOS in what is called, for some reason, the numbering is weird. Like the actual, this is the, there's actually more partitions here, but you can only see some of them. So the way this works is you hit partition, it will actually show them to you. So there is a first partition here that shows up as unknown, and that's actually the pre-boot, that's the system partition that holds files that the bootloader, that the sort of the firmware that is in a separate boot flash looks at. And this is where boot policies are. And it's basically just boot configuration. There's actually multiple. This is an ABFS container with multiple subvolumes. And the first one has boot policies. The second one has secure enclave processor data. And then there's one for like hardware logs and miscellaneous stuff, if I remember correctly. And disk utility hides this because it's being a bit of an asshole, but it is there. Then this is a normal Macintosh APFS container containing normal macOS. This is a macOS that is being replaced with Linux, and this is you can think of this partition as if it were the EFI system partition on a UEFI Mac, as in it's a thing that we need to make this all work. And this is where Mini is installed right now. But this also has a full macOS on it right now because for a bunch of technical reasons, the only way I could get this to work is to install a full macOS. But I could delete the macOS subcontainer, resize this down to like 1 gigabyte and make space. It's just that I don't want to do that right now because I might, for some reason, want to boot back into macOS at some point. But eventually, one way or another, this will be a small APFS partition where our bootloader is installed. And that's what is required to gain control over the system. And this partition has to contain also a second stage bootloader, another version of iBoot, and some other files and firmwares and things. And we cannot control any of that. So that has to come from macOS or from recovery mode or something. I actually have a pending experiment to see if I can get away with copying those files from this, which is actually the recovery partition. Because if I can do that, then we don't need to like we could have a Mac with only a recovery partition and bootstrap and blank Linux install in theory. But right now, it's just a dummy macOS that I'm replacing the kernel with Mini on. And so eventually that will just be, a few Apple files we cannot control, and then Mini and nothing else. And then these two partitions are currently in use, but the idea is that this one here is going to be our normal Linux/boot partition, and I'm making it FAT32 because that's the easiest thing to implement in Mac, Linux, and a bootloader. So probably our boot partition will be canonically FAT32 on Linux and Apple Silicon. This is not rare. I mean, Raspberry Pis do that too. I could add like ext support, but like, what's the point? FAT32 works from Mac and from Linux, and there's embeddable FAT32 implementations that are very easy to use, and I've used them. So we'll probably make FAT32 our canonical boot partition file system, and then this will just be like ext or something. It's FAT32 right now because I haven't reformatted it, but this will be Linux. You could partition this however you want. This whole disk is just a GPT disk. So that's how the whole layout is going to work. Of course, right now we don't even have drivers to access this internal SSD, so this is all academic. Only this APFS container is being used by iBoot to boot our Mini stuff, and then we have no disk access. But eventually that will come, of course. I'm kind of hoping that the SSD controller is fairly sane. I think there's a separate chip that handles all of that, so like a separate CPU, inside the M1. So hopefully there's a reasonable enough interface for talking to it. So hopefully that makes sense now. And if you actually want to see what this looks like, I'm actually going to... Well, let's just use the terminal here for... And it's fine. So if you want to see what these actually look like on the terminal, and let me see if I can make this a bit larger. The annoying thing is that this is a US keyboard layout, and I actually don't know how to change it to Japanese. Like, this doesn't work. Even if I said this, the Japanese something, it doesn't work. And apparently my notifications from Chromium show up in here too. I should turn that off. But yeah, so you can see there's some of these are virtual images and don't count. But this is the GPT layout. And so that's I mean, that's not a partition, that's just fake. This is the first partition, that's the iBoot system container. And then we have the macOS install, the Linux, let's call this Apple Silicon boot partition, if we make up a name for it. And then the partition I have reserved for Linux boot, and the partition I have reserved for Linux data. And then finally, this 1TR is stored in the recovery partition. And so these are the volumes inside the containers. They're both macOS installs right now. We will need, in principle, I think, to boot macOS. I did some experiments earlier. We only need, I think, pre-boot and the main OS, maybe recovery. We definitely don't need a separate data volume. In the bootloader only cares about pre-boot, but in order for the tooling inside 1TR, this starter disk thing, to recognize the whole container as like something you can boot, you need a couple files inside the main OS volume. But anyway, this doesn't matter because these whole things share disk space anyway, and this partition is going to be like a gigabyte or so at most, I think. Maybe a couple. And so then what I can do is, unfortunately, this doesn't actually show all the hidden stuff in ISC, but I can do this. Oh, there's no, sorry, dash p list. Yeah, so it's not going to look nice, but what you can see here is there's actually, is there a PL, a nice, can PL like printplists in a nicer format? Can you tell I'm not a Mac person? There's no help. That's annoying. Yeah, probably. Anyway, whatever. So in the iBoot system container, which you can see here, I think. No, hold on. I need this, probably disk 1 or something. Hold on, not 0s1. It is here, yeah. Stores. Yeah. So the first subvolume is called ISC preboot, and that's where the boot policies are. The second one is called XArts, and this is basically Touch ID and other stuff that the secure enclave processor stores. Hardware just has like random logs and things. I think it's used during testing and other stuff. And then what was the last one? Oh, this is the recovery, but this is actually empty. I have no idea what this is doing here. I think it's just that they created by default or something. It's completely empty. Like I can mount. There's lag in the capture card and it confuses me. It's like working over SSH. So yeah, so that's that. And if I look at what's inside, it's all that gets mounted in system volumes. So in ISC preboot, you can see it fits nicely in one page. So these are the boot policies for the different OSs that are having installed here. I think there's probably some junk. But it includes the recovery mode and the custom, the Linux OS and the Mac OS. And the SFR is the system firmware information, basically the combination of one true recovery mode and the stuff in the NOR flash on the system. So this is all managed by Apple anyway. Under XArts, it's literally just one file with stuff. There's a tool for managing this thing. You can list it. It has to do with the SCP. Like if you wipe this, then it'll delete all your credentials and things like that, I think. Then under hardware, it's just some logs and some factory. I think this all gets copied from the NOR flash, so it's not like if you delete this, your thing is... that's right. It's not like if you delete this, your thing is bricked or anything. I don't know what this is. Maybe it has to do with hardware sensors or something. And this is presumably a copy of the files that came from the phone home system when the whole thing got installed or the last time it happened. And that's basically it. So this is all, like, we might have a use for these files if we cannot get this information elsewhere, but other than that, there's nothing more to do here. And recovery is empty. It isn't even mounted. I don't know when that gets created. And then So disk 3 and 4 are just the OSs. So if I go to the important stuff is volumes, Linux and volumes pre-boot. So the pre-boot partition is where everything we care about is, and this is where I had the... Actually, now that this works, I can probably delete that beta 1 thing. But I was doing this at the beginning of the stream. And basically what's going on here is you have... I think this restored directory is basically the system firmware dump, and is used for firmware updates and stuff. I don't think any of this is actually used when booting, but I think it's used again by this boot picker thing. So we should have this directory in there to make like Apple's tooling work. Though to some extent we should be making our own tooling at some point. And then can I scroll back? No, is there a command page up? Yeah. So this is just, it says EFI, it's not EFI, but these are like resources that Apple uses for boot and other random junk. But the important part is this. If you go into boot, and this is a really long directory, but if I go into 5.8 boot, and there's under boot system, there's nothing here. Active is just a file containing the name of that thing. And if I go into that directory, make it a bit easier to see. So you can see that we have, this is actually what matters. This directory is what is getting booted by iBoot when you boot this OS. So what you have here is this user standalone firmware stuff is what we don't control. We need to copy this from somewhere, macOS, or if the one true recovery files work, then I will probably use that because we can guarantee that it's there. But this is basically still part of the secure boot chain provided by Apple. And presumably what broke when I updated to beta 2 is that beta 2's system firmware and recovery cannot boot beta 1's this for some reason. So the chain here is the boot ROM loads the first version of iBoot, which I don't know if they still call it LLC. They might. LLB, sorry. From NOR-Flash, which is a flash chip, kind of like the BIOS chip on a normal PC. And then that's going to go find the boot policies in the first volume that I was talking about, the ISC pre-boot volume. And then once it finds a boot policy that it likes, it will look in here and load these files. And then like this iBoot is going to boot and load these firmwares, which is nice. Like all these firmwares in theory, I think, get loaded for us, so we don't have to care about them. And then that is going to go in here. And AP ticket is basically in this case, it's the non-personalized one. So this is basically Apple saying you are certified to boot this OS, but in fact, because we have disabled security and installed the custom kernel, you don't need more than like the one that ships with macOS. So basically, I don't even know if this is needed, but if it is, it's just the same as these files. It's something we copy. And then this is macOS, the kernel cache, and these custom ones are the ones that are mini basically. And so this is where we put our bootloader, and that is done automatically by kmutil, which is the configure boot thing. So that's where you can just pass it a Mako file, and it will copy it there and do all the magic. And so what ends up happening in the end to make this all work is that that file gets sort of hashed and inserted into your boot policy. So the Mac will only boot that one particular version of Mini, which is why to update that loader, we need to go into one true recovery. There's no way around that. And that's part of their security model, which is why I'm doing this chain loading thing, because it makes it a lot easier. And similarly, obviously, we're not going to put the Linux kernel directly here for that reason, because you want to be able to update your kernels. So to update, what we'll probably end up doing is making it so that, for example, let's say if we ship Mini as a Linux package, then what we would do is have the package copy Mini to, say, the FAT32 partition, which is easy to share, and then tell the user to update Mini, go into one to recovery, and like run /volumes/ whatever the FAT32 partition is /something.sh, and then that will call kmutil for you and install it. Which is not too bad. I mean, I mean, to be honest, like when I install a Linux system, I don't even update grub like ever. Like grub gets it's installed when I install the system, and then I, because grub also gets installed to user first, and then you run grub install to put it on your disk. And honestly, I don't even remember the last time I updated grub for a reason. It's just, usually the version that works when the system got installed just works forever, because it would be very rare for something to need updating in the bootloader anyway. So I don't expect this to be a big deal for users, especially once everything is working fine. Updating bootloaders is a rare thing. But yeah, so that's basically how this works. And as for initial install, ideally, if everything goes to plan and we figure out the things we need to figure out, it will be something like, I will at least use HTTPS. But basically, this is going to be our install process. I mean, we'll have some offline version and things like that. But this is going to be the simple version. You go in here, you pull this up, you run that, and then follow the instructions. What about loading a new mini from disk? Yeah, I could do that. I could chain load mini. And in fact, because I'm going to have a chain load feature in mini anyway for booting, whether you want to boot Mac OS, or if you want to mess around with like the Mac OS kernel, that could be useful. But also to boot itself. So there's no reason why you couldn't configure mini on this partition, like to load another mini from another partition, and then, yeah, I mean, especially if you're developing or updating it frequently, that makes a lot more sense. So yeah, I mean, this once we have support for booting Linux and for booting macro files, there's no reason not to support loading another mini in the production version anyway. And grub can chain load itself too, right? So hopefully that makes sense. Yeah, I'm calling it mini, but this time it's spelled m1n1, but I'm still calling it mini. It's not the same thing, but it's pronounced the same way, and it shares some code. For those of you who don't know, when I started doing this very exact same thing on the Wii for the same reason, it's almost literally like a one-to-one copy of what I'm doing here. When we were messing around with Wii hardware and learning about it, I built this, originally this exact same thing, a UART proxy. And I did the same exact thing. I replaced some OS installed on the Wii with it, because that was the only reasonable way of making this work at the time. And it was called, and the Wii security CPU OS is called iOS, all uppercase, no relation to Cisco or Apple. So that's another funny thing. And at the time I called it mini iOS because it was like, a very small replacement for iOS, but it isn't actually iOS, and it doesn't do what iOS does. And then I realized that mini itself could be backronym into mini is not iOS. And so that's what mini stands for. So it got renamed. And then eventually, when we realized that, so that was originally just for experimenting from a computer via UART. But then I realized that we were going to run Linux on the Wii, and that we had a hardware access problem where Linux could not directly access hardware registers that it needed access to, but Mini could from the other CPU. And so this whole proxy thing was reworked into that's why it has the fixed structures and stuff. That was all made into a very fast interprocessor communication API. And the idea was that you could like post register writes in nanoseconds from the main CPU and get register reads in microseconds. And then we had Linux literally proxying all the like USB register reads and writes through Mini. Again, remember that Wii has two CPUs, so Linux is on the main CPU, Mini is on the other CPU. And then eventually we found a register to just allow Linux to access everything directly, and then this was all not necessary anymore. But we still use Mini on the side CPU when you run Linux on the Wii, because it makes sense, because it lets you do these things directly, right? And so Mini started off as that experiment replacing iOS. Then we, when we shipped BootMe, was when all this got sort of deployed. So if you install BootMe on a Wii, our bootloader, which is BootMe itself, it's kind of it means two things at once. But the bootloader will load Mini from your SD card. It doesn't overwrite any OSs these days. and then that will actually run a little boot picker UI, which is not unlike the thing that that Apple Silicon is doing here, that will let you like boot normally or back up and restore your stuff or do some advanced things. And you can replace that file with Linux, and instead, your Wii runs Linux. So kind of a different model, but in some ways very similar to what I'm doing here on the Mac. And so that code base was, it's really not anything complex, but and I'm putting things in as I go, right? And so that got ported to a Chinese MP4 player we were messing around with. And so that's where the SPMP version came from, right? And so that's why I'm copying the UART stuff from there, because that's sort of the revived the UART code, right? Like we had the iOS proxy UART code, and then that whole mini got turned into the IPC proxy for talking from the other CPU. But then when we did the MP4 player thing, we went back and I made it work with the UART again. So I put that from there. And then, yeah, like I'm just pulling little bits and pieces, and I ported it to ARM64. And sort of interestingly, I will probably steal some code from Asbestos, which is my PS3 Linux loader, because device tree management functions that all came from Linux. That's all. It's actually I think it's not GPL. I think it's a more permissive license. I hope it is. But there's device tree management functions in there. And so once we get to the point of loading Linux and managing the device tree, I will steal some code from Asbestos, because that's also handling that. And Asbestos, I think, also had a very simple boot configuration file format that I implemented. So I'll probably take all of that parsing code from there. So eventually, mini spelled with ones is going to be an amalgamation of code from the latest version of Mini for the Wii, code from the SPMP version of Mini for the Wii, and code from Asbestos for the PS3. But why not, right? And like the nice thing about this is that it's like, maybe eventually we will want to use like U-boot to boot Linux on Apple Silicon. Like that's fine. But this is a very small code base that lets you mess around with things very quickly, and has this whole serial thing, and it's very easy to understand, right? So also it's the smaller the code base, the less likely you are to break it if you do something dumb. So the next thing I'm going to do once I fix the watchdog timer is figure out how to add exception vectors and start getting sort of safeties in, so it doesn't reboot every time I mess up. No, there's no way of booting. Apple Silicon does not boot from USB. It doesn't even have USB drivers. So that's one thing that is very different between iBoot and Intel Macs. Like Intel Macs have an enormous operating system built into Flash called UEFI, and it's completely ridiculous. iBoot has nothing to do with that. iBoot is an extremely simple bootloader. It cannot use the keyboard and the mouse, which is why all the option whatever command shortcuts have disappeared in Apple Silicon. All you can do is enter one to recovery, and then there are a few options like keyboard keys you can hold down to do things from one to recovery. So yeah, like if you want to recover an Apple Silicon Mac that you've totally messed up the disk on, you have to use DFU mode. You have to plug it in as a USB device into another computer currently running macOS. But again, one of the things that is in scope for Asahi Linux is contributing support for this to iDevice Restore if the maintainers don't do it, don't beat us to it, which is a Linux clone of the Apple Configurator 2 thing that does this on iOS devices. So like most of the scaffolding for that is already there, so it should not be a huge project to add support for it. And so it's not 100% clear what the install process is going to look like, but sort of it looks like right now, worst case, the way it's going to work is you will need a macOS install originally to run part of the Asahi Linux install process. But if we get lucky with Apple, because Apple is still iterating on all of these, KMUtil just showed up last night. But I'm sure the way 1TR works is going to change and stuff like that. So depending on sort of where they're going, and if I'm guessing by the direction they've shown so far as to how they're, what they want to do and what they don't want to do, right? Because like if you think about it, like it's clear that Apple's goal here is to enable, like they want to be able to say that the Mac is an open platform and that they allow people to like mess with their Mac OS kernels, right? But they also have a very strict security requirement that basically, they can't let people pwn themselves by accident or something. So, which is why kmutil will prompt you for your password and things like that. Like it's a very, very complicated security model. But like there's things they care about and things they don't, right? So like once you're in one-to recovery and you've asserted that you're physically at the machine because you held down the power button, and then if you type in your credentials into kmutil, you're basically, like at that point all security bets are off for that OS, right? So that gives you an idea of sort of what their security model is. So if we're lucky, they will sort of open things up a little bit more so that we can build less awkward tooling for users to install Asahi Linux. But given the way things are currently now, and my best understanding of the boot process, the most complicated installation process we will have at this point, the worst case, is you do the curl sh thing. You install macOS first, which you would anyway, because you need to like DFU mode will install macOS for you. So assuming you have a Mac with just macOS on it, you would run the curl sh thing in macOS. It would do a bunch of stuff. It would tell you to reboot into one-to recovery and then run the curl sh thing again, or maybe just run a shell script from disk that gets put into macOS, and then that would complete the process. So it would be a two-step thing, which is not terrible. But if we get lucky, we should be able to, if Apple improves the way all of this works, because like the reason why we're a little bit restricted right now is that we depend on Apple's tools, and sometimes those tools, because from one-to recovery from this environment, we can't run binaries that we sign. Everything is code signed. But we might be able to use Perl or something like that to like do a CF, like a foreign function interface thing. So if we figure that out, or if Apple makes our lives easier at some point and gives us more options here, we should be able to install Linux from one-to recovery entirely without having a working Mac OS. So that is, yeah, so what's stopping us is the fact that we cannot run our own code from one-to recovery. And the main problem is that kmutil wants your username and password for that macOS volume you're kmutiling. If you don't have a macOS volume, there is no username and password. And the only way to insert that username and password is to boot into that OS, because that's SEP backed. So it's not like just a file, a password file that you copy. And so in principle, there should be, like, for example, that it's the same problem we have with an external macOS install right now. If you install something on one Apple Silicon Mac and try to boot it on another Apple Silicon Mac, it doesn't work properly. It kind of works, but it doesn't work properly, and that's part of the reason is that like the booting from another volume isn't like dealing with the credential stores properly. So again, it's the whole M1 was obviously rushed thing. So like we know things are going to be changing because they are improving things, not just kmutil, but they're definitely like booting from external devices. I think didn't work at all on the launch firmware, and then there was a day zero patch and stuff like that. And they obviously still have things that are like genuine bugs. So that's our chicken and egg problem right now, is you need a full macOS installed in order to set up a user with a password that then we can type into kmutil. However, if they fix external drive booting, then there must be some way of like adopting that credential from an existing macOS install. And then at that point, it wouldn't have to be a true macOS install. But because we would have to still run our own code to do that operation, which is the same kind of frameworks that a macOS installer would use, we can do that from macOS, from another macOS install, because that we can just run on-site code there. Of course, you can turn off the security. I don't mean the kernel security. I mean just like the usual, like like ad hoc sign code thing, the normal thing. But then you still have to go into one-to recovery. So that's our current sort of chicken and egg situation, right? That we can do custom flows in macOS, but not quite in one-to-recovery. If someday we can do custom flows in one-to-recovery, either by finding a workaround or if Apple, gives us a way, then we can do everything from one-to-recovery. So hopefully that made sense, and hopefully that someone will find the timestamp where I explain all of this in this video and save it. And actually, I'm thinking that I am recording this. Once this video is done, I will probably cut out that little bit and upload it as a separate YouTube video, and that way people can have it sort of standalone. Okay, so hopefully that all makes sense. Back to bring up. But anyway, yeah, I mean, you can literally just go in here and pick Linux and it works. And by the way, like behind the scenes, this does magic. For example, like if this were something that is not set up on this machine yet, it would actually go create the boot policies and then phone home to Apple, because if there's no boot policy, then security is enabled. If security is enabled, then Apple requires checking that the OS you're booting is the latest version of macOS. Basically, that when you provision a boot policy on a new Apple Silicon Mac with security enabled, it's the same thing that iOS devices have with phoning home to check that basically that it's the latest version or something. I think when they update, like they still sign the previous version for a while. But the idea is that if you have full security enabled, you're not allowed to install old vulnerable versions of the OS. One thing I have noticed, because it glitched, I tweeted about this earlier today, is that if you're doing an actual macOS install with the installer, and if this process fails, or if Apple isn't signing it anymore, but you're doing it from like one-to-recovery, it actually just tells you, this is an old version, do you want to run in reduced security mode? And so, like, again, it's clear that Apple are very, and that was like a nice dialog box and everything, right? So, like, it's clear that Apple are very openly saying, we are implementing the iOS full security model on Apple Silicon Macs for the benefit of users, and that will be the default, and that will be the way 99% of macOS users are going to use their computer. And then if you want to, of course, at the kernel level, right? Now, at the application level, everyone knows the code signing thing and how to turn it off in system settings. But at the kernel level, we will do the iOS full secure boot process, and then if users give consent to bypass things like the requirement that you're running, that you install the latest version of macOS, that's fine, but you have to give consent. So it's very clear that their approach here is basically, they are giving people the option of having an iOS-like ecosystem for security purposes, but they're giving people the option of turning that off in various levels and degrees. It's in system integrity protection. Actually, the most annoying thing right now about Big Sur for me on macOS is the signed system volume thing. You can turn the signing off, right? That's the part that guarantees that after the kernel, your OS partition is also all signed and verified. And you can turn the setting off, but you still can't just modify things in the root partition because it still is an APFS snapshot. And I think there's no way to just mount, turn off the snapshots and just have a read-write root file system. That seems to not be possible right now, even if you turn off all security. It's just the way the code in the kernel is written. I mean, you could patch it, of course, but there's no nice way of doing it. That's the thing that annoys me most right now, is that there's no way to just have a wide open Mac that lets you just edit files in the root file system the way you used to be able to in previous versions. Someone said I have an interesting accent, sounds like 3 different ones blended together. That's because it is. That's because I'm Spanish and I have lived in the US and in Ireland. So my accent is going to be some strange mix of Spanish, Irish English and American English. I've had people tell me that my accent sounds like all of those 3 things, depending on whether they picked up on. Anyway, hopefully that answered a lot of questions. And yeah, as I was saying, like this boot the OS selection. It actually does other things behind the scenes. So one thing you can do is if you get a shell remotely in here, you can watch the logs while that happens and see it, phoning home and everything. Okay, so we're back, so that works fine. And this works. Okay, so what about that watchdog timer? I'm pretty sure, I don't know why this, that's just one thing one problem that I have is that, I'm going to need a nice parser for this device tree format. And, Mac OS device trees and Linux device trees are different, but they're kind of the same thing. They're both based on the, open firmware device trees. So it's very, very eerily similar, but not compatible. So, yeah, let's see. So we had the Chromium stuff. I'm pretty sure I needed 2 there. I think the device tree parser I'm using for that isn't good. So, is it rebooting now? Hello. There we go. C and 1C. Oh, that's a 4. Okay. Is this all I need? We'll find out if it doesn't reboot anymore. Looks pretty good. Not rebooting yet. Yeah, I think we got it. Excellent. Who found that again? The Project Zero watchdog thing? Thank you for that. All right, so that's going to go into my main. And for now, this is actually in the device tree, so this should be parsing the device tree and doing this properly. But for now, we're going to do it like that. And I do want this flashed because I'm going to it's really annoying if this reboots every time. So thank you, Shiz. So we're going to do one to recovery run. And yeah, I think some people have mentioned this, but what I'm doing when I go into this one to recovery thing is actually I'll full screen this so you can see what it does. I have a keyboard emulator plugged in. And then basically this will load a shell script. So once it goes into one to recovery, I emulate some keystrokes to get into a shell and run curl, and then that curl thing is going to run this type thing, right? It emulates a keyboard, and it's going to run that, and then that script is this, which is going to get mini. This is because I want this to work even on one to recoveries that have the old KMutil. So I wouldn't actually need this. I can just use the one that comes with it, but since I was juggling beta 2 last night, I was just copying it from another machine. And then it just does configure boot, and then it just reboots if it worked. So yeah, if I run this, you'll see what happens. It does this keyboard emulation thing. It picks that option, waits a little bit. And this is all hands-free. I'm not touching anything. Opens the terminal, types that. The blinking, by the way, the noise is just my capture card being stupid and probably HTTP related. It actually takes a while to build the boot policies. There's a lot of plumbing behind the scenes to check all the files, and then it reboots. So very convenient for testing. The only thing I have to do is hold down the power button. That's the only annoying part, and it takes a while. It's a face dancer. It's called a face dancer. You can Google it. It's a very it can only emulate very simple, very slow USB devices, but it's good for fuzzing and for emulating keyboards and things like that. we actually did the same thing when we were doing Linux on the PS4. Like we had to go into a menu to trigger the exploit, and so we were emulating a keyboard and pressing the arrow keys to get into the menus and stuff. Okay, so hopefully that worked. Proxy client, yay. Let's skip yay. Yeah. Cool. So for example, I should be able to do something like memset32 ba.video base, and then just do like some color and 1 kilobyte or something, and that should change the, or not. Or is this because of my? Oh yeah, it does work. Yeah, and my capture card has the thing where at the top is broken sometimes, but yeah. So right to the frame buffer. If I had the bandwidth, I could be playing Bad Apple on this thing via serial streaming, but I'm going to avoid going there. Actually, here's a fun thing for the, what's the name of that thing? The MicroView, which is like an Arduino thing with an OLED screen. The bandwidth required to stream 1 BPP images to a MicroView over 115K baud serial is like exactly the bandwidth of 115K baud serial. Which was kind of amusing when I did that, because I did put Bad Apple on that. But yeah, let's not go there. So, yeah, so, okay, we got the watchdog timer, so we can play around now. So the next fun thing to do, to be honest, the next fun thing I want to get is a USB, because if I can... yeah, the Mako loader can wait until later, because I can't... this takes forever to upload. Oh yeah, sorry. Now the watchdog is done, I'm gonna get the device tree out the way it's dev tree minus ba.virt, because for some reason this base, and then it's like read mem that ba.dev tree size. I should actually add my another progress to read mem, but how long is this thing anyway? Hold on. It's not that big. At least in binary it'll work. Oh. Oh, okay, I see what it's doing. It times out on... Yeah, and now that happens. It times out on... Yeah, okay, so I need to change that. It's not like that. It should be... Let's just do... That should work. Still crap coming in there. Okay, it was in buffer. I think Alex Graff asked me for this. I don't know if he's watching on YouTube or not. For Bad Apple, that the obvious thing I need to do is like not have the Asahi Linux logo, but have the Apple logo, and then have that morph into the Apple at the beginning of Bad Apple halfway through. Like when the screen changes, it gets inverted, right? Like it skip the intro and somehow like morph that. Like have it just rotate, morph, and then the song kicks in. All right. I don't know how many personal secrets I'm leaking with this, but if anyone wants to download this, feel absolutely free. There'll be a URL on the screen right now. But I'm going to send this to some people directly. Feel free to download that if you feel like it, if that's useful. And yeah, so actually it's because I need to get device stuff from the device tree, I'm going to say the next step is going to be parsing this. I'm having some C code to parse this. I don't know how close this is to Linux device trees. Let me get a real shell. I'll screen the shell. What memory address? The one here? Are we talking about the one in main? This thing? This is the watchdog timer disable poke. So yeah, the device tree is how you configure devices on Macs, and it's all started with PowerPC. Basically, the bootloader tells you about the machine you're running on via the device tree. It's very different from PCs. On PCs, there's ACP that does a bunch of that, and then there's auto detection for PCI and like all the plug and play things. That's not how embedded platforms work. That's not how Apple Silicon works. That's not how almost anything else works. And PowerPC did the same thing. So the idea is that the bootloader knows about the machine, knows what hardware you're running, and it gives you a giant data structure with telling you, like there's USB is at this address, and PCI is at this address, and that you have this many CPUs with these capabilities, and it's like you can think of it as like a JSON type file format. It's like names and values and structures and nested structures. And this all came from PowerPC, and so Mac and Linux stole that in different ways, and so this device tree is extremely similar to Linux device trees, but the details are different enough that we can't actually use it directly. So we will be building our own Linux device trees from scratch because it doesn't make sense to try to translate, really. But so it will be manually translated, right? Like humans will be me basically will be taking the device tree for every device that Apple releases with Apple Silicon from now on and making a Linux version of it. But and it's not that bad, like a lot of people shared. But because there are contents that get changed by iBoot and things that are dynamic, Mini has to take the macOS device tree we get from iBoot, find those things that are not universal for all devices of this type, also find out which device this is, because I want this to be universal enough, and insert those back into the Linux device tree. And we also have other things that we will insert into the Linux device tree. For example, the kernel command line goes into the device tree on Linux. It does not on macOS. So yeah, like there has to be a bunch of management code for this. And so, for example, this watchdog timer nonsense here is actually in the device tree. So I don't want to hard code this address. This should be parsed. So once we have parsing code, that'll be nice. So the only problem right now is that every time I run Mini... Oh, no, so I can chain load Mini once, but I can't chain load Mini twice because it will overwrite itself. So what I actually should do... I have a get base right now, but I don't have a get size. I can just cheat and do like 1 megabyte anyway, because it's not 1 megabyte. This chain load thing, right? It should be like new base. I think eventually I have a macro loader that can replace itself in the same place in RAM, but not right now. So what I will do is new base is top of kernel RAM. So what I'm going to do is new base is equal to base. So let's see if that works. That's a good thing to test. Proxy get base. And new base is actually going to be base plus where macOS told us we had space, which we don't have a kernel size, do we? No. But this is going to be guaranteed to be larger than the kernel, so add that minus BA dot. That is virtual, is it? No, it's not. Fizz base. Yeah, something like that. So that should guarantee that I can reload Mini multiple times. Make sure I'm built. Yeah. Let's see if that works. Oh, it's the logo version. Well, at least it's not going to time out now because I finally have the watchdog timer fixed. But I do want to turn that off for faster loading. Let's is the Macintosh apple. Asahi. Well, Asahi just means rising sun in Japanese, and there's a ton of things called Asahi, but one of the things Asahi is one variety of apple, and it is the Macintosh apple. A lot of Japanese people don't know that. Also, I don't need this anymore. So let's see if I can rechain load. Loads to 7E. That is greater than before. Yeah, cool. Oh, something broke. That's interesting. It's alive, though. Is it? Yeah, no, it oh, there we go. That's weird. Oh, I know what's going on. Because this gets buffered, it's still sending bytes over while I'm... the Glasgow is still sending bytes over from its buffers while I think everything is sent. Like, there's no flush, right? That's what's going on. And so then it times out. So I make the timeout like a bit longer and it should be fine. I bet it's just like... How much is 1 second that... it's like, yeah... it's like 11K, and we thought the how big was that thing? 8K. Yes, it's like just right. So my timeout should be like 1.5 seconds. That should fix it. Another nice thing I should add. Yeah, there we go. Actually, you know what? Before the dev tree, I'm going to add another level to the stack. I want an upgrade baud rate function. I bet I can do at least like a megabit or something like that. So let's do a bit of experimentation. I know the UART is at this address. That's another thing that should come from the device tree, by the way, but I would not want to do that during early boot. So, and there's this baud rate register thing going on, right? So UBR div is 28 and fracval is 2C. That's pretty small, actually. So let's see if I can find the docs for this. And Samsung should have documented all of this, I believe. Because I think all the Samsung chips use this. So what's the Samsung, like... I know like some of the ARM 926 CJSs used to do this. And like, let's see if I can find some real docs on like SC3 chips and stuff. Like, for example, that. I don't know. Yeah. Any of these documented? I know some of them used to be. Again, this is just random, but like all the Samsung stuff uses the same EU. Not installation. Nah, C3, whatever. G440, what is that? That might work. Yeah, it's the Exynos UART. I don't know if Apple is actually using Samsung IP here or if they just cloned it. Not like it's hard to re-implement a UART anyway. And Linux has a driver for this. Actually, one funny thing is that Corellium re-implemented a driver for this in Sandcastle, even though Linux already has a driver for ostensibly the same UART type. So I don't know if it didn't work and they just didn't feel like patching it or what. If it's too different from Samsung, but I'd be surprised. What? Oh, I saw that, yeah. My screen. But some people are going, you should use a tiny window manager, it does this for you. Yeah, cool. Of course, there's no freaking... Yeah. Okay, so how does that work on the registers? I don't know if the... Well, we'll find out if the baud rate is right this time. And I bet the frac val isn't even implemented here. Yeah, so let's see what the clock is. It should be 16. Okay, so it does like 16 times over assembling, and then it's +1. So in principle, if we do 200 times 16 times OXD and not hex, that sounds like a reasonable clock. 24 megahertz? Cool, so the clock is probably 24 megahertz. I bet that's in the device tree somewhere. So in principle, if I do 16, the fastest clock I can do is 1.5 megahertz, which makes sense. How fast can Glasgow go, actually? I think it can go pretty fast. So, yeah, let's see. One thing that Glasgow does is auto baud rates. And so one cool thing that I can probably do is, because I don't think it's going to listen to me changing the baud rates here. I don't think so. I don't think that's implemented. If it is, that'd be really cool, though. Let me do a quick check and look at the Glasgow code. See how that's implemented. Software, Glasgow, applets, interface, UART, PTY. No, I think that's automatic for the PTY stuff. Oh, sorry, wrong screen. Add parser, PTY, master, open PTY, forward. Yeah, it just does a forward, and forward probably isn't going to do any kind of baud rate handling, I think. Nah. It's just, yeah. That's fine, though. So, all I have to do then, in that case, is have the baud rate change function output a bunch of, just like maybe a few bytes of stuff to the UART, so that primes the Glasgow baud rate detection. But yeah, how fast can it go? I actually don't know, but I'm guessing it can go pretty fast. This is saying 5 megahertz, so... let's try 1.5 megahertz, see if it works. I'm gonna go all the way. That's gonna break this time. That's okay. And this is gonna change my PTY. That's annoying. But let's turn on auto baud rates. And that's... Oh, but it's not going to detect it until I write to it with the right baud rate, which is annoying because it's not... Yeah, so I do need to send the... Yes. And this... Oh, it is correct. Cool. Wait. Yeah, it worked. Cool. Yeah, because it said on this side, the baud rate here doesn't matter. Excellent. And now it should be way faster. So if I like chain load something, it's going to crash after the chain load because it's going to have the wrong baud rate. But that's fine. Oh, no, it's not because I'm not changing it. It will stick. Yay. Cool. Excellent. I like it when things just work. So we are now at 1.5 megahertz, and life is a lot easier. Yeah, so we are going to add the change baud rate thing here. UBR div. The ufrac val thing should be for, like, when it's not an even divider, but, whatever. So the clock should be, what did we say it was, 24 megahertz? Yeah. What is that thing? Not rounding properly here, but actually let's do a bit of minimal rounding. Something like that. I think that's right. Maybe, yeah, something like that. And add a proxy operation for that. Proxy. Actually, you know what? I might want to get baud, because that way I can upgrade the baud rate automatically when it's too slow. Because this, since it's all automatic on the Glasgow side, this can't actually know what the current baud rate is without just reading the register. But then reading the register is the only way, isn't it? Yeah, for now let's just read the register. Cassette baud, I want it to be sort of atomic with the writing some junk on the output. And in principle, that should just recover if I do it that way, basically. If I do in Proxy C. I don't need a red bound, that is just break, but basically. Set to that, and then what I'm going to do is make the things that I print configurable. So argument 1 is going to be how many bytes I send, and then I'm going to do, well, it can count minus put byte request args2. And so it's basically defining how much dummy data I send thing. And I actually want a print on this. And I want this to change the baud rate only after the FIFO has been emptied. Oh, I need to look that up because I know the bit for FIFO is full, but not for FIFO is empty. Where are the registers on this? Oh, interesting. There's a kind of blocking thing there. Yeah, I know. I don't need. That's why I'm doing this. This thing with a put byte with a bunch of crap, right? So it'll just add some padding to log onto the new baud rate. The main problem is going to be in the other direction, right? When I start talking, like when I reboot, there's no way I can tell I had to restart Glasgow basically at what 115. So basically, what I have to means is that when I reboot the machine, I also have to restart the Glasgow client at 115k baud, and then after that, everything should work. We could probably automate that somehow, but UTR stat, I think that's what that's called. Yeah. There we go. That's the thing. Oh, yes. It depends on the buffer, right? Transmit buffer empty. But if this is... That might actually not be using the FIFO right now. which is fine. I don't actually care about the transmit FIFO that much, but this is checking. Oh, this is checking bit 2. Bit 1, sorry. Transmit buffer empty. I think the FIFO is not in use, actually. Yeah, this is the bit I want, is 4. In principle. The Mac is not silent at startup. Oh yeah, you're right. So it should lock onto 115K on restart. Yeah, it should be fine then. Cool. That is bit 2. That's what bit 2 is. It's a 4. It's that's the same thing. These should be defined later. They don't even have like proper names for the bits. Put bytes that baud. I need to include UART.h. Huh? I have a dumb printf in here, Sarah. Yeah. I guess I really should just do this in set baud. Actually, I forgot to clang format this when I committed. I need like a pre-commit script that does that. Not UBRDiv, it's just UBRDiv. Let's see, will that work? Well, I'm not doing anything different now. So in principle, if I do Python shell, and I want to add this here, proxy py, and the arguments where, how do I call that? And count is the next one. So 64 characters should be enough. I'll just give it like AA or something like that. Let's see, that's a nice, that's 55. Ew, that works, yeah. Hopefully that'll get it to lock. And yeah, that should just lock and then get the reply properly. I don't need a red file on that. So let's downgrade to 115K baud. That seems to have worked. Yeah. Is it actually working? This isn't showing the... There's a verbose thing I can do on Glasgow to show that. It might not be doing anything. No, it's not. Also, why 64? That doesn't make any sense. No, what? I'm not passing butter to the request, indeed. That'd be helpful, wouldn't it? Cool. That works. I should have a disabled TTY thing for that thing. Let's try that. That still didn't work. Why? Is the math wrong? Yeah. No, that's correct. Oh, hold on. No, it is. Yeah, okay. Wow, I'm surprised that didn't crash. It did switch, and then timed out, and then got the bytes afterwards. So why did it time out? I think I need more. I might just need more time because of the Glasgow change. Just try like a 5-second timeout. No. Also, that's interesting. Like, why do I get that junk after the UART timeout? Oh, is it because of a new line? Oh, probably just that then. Hold on. I should be flushing. Standard error and standard output, right? Yeah. So it's not the timeout, it's that something is broken. Why? Just do a quick print in there, see what bytes I get. Hmm. 66x4C. Oh, hold on. Oh, hold on. Stop bits. Yeah. It isn't locking because of stop bits. It's not. It's a string of adjacent characters with one stop bit. So it's going to go like low, high, low, high, low, high, low, high, low, high, low, high. Yeah, that's why. It's a framing error. So I need something that will give it. Yeah. That is not the best possible character to use. Instead, I probably want something like, and this is why I made it configurable. A is more likely to work. Or not. That worked. Okay, so going faster doesn't work. Going slower does work. No. No, it still doesn't work. What character is there anyway? Z. No, the thing is, like, if this has one, think about it. If it's 55, no, but if it's 55, right? It's like it's start with 101001. Let's try that. Yeah, that works. No, it only worked once. Oh, now it works. Yeah, now it works. Almost. Maybe I need a bit more. Yeah, see, that works. Almost. Sometimes. Why does it break sometimes? Why does it get zeros from? This might be a Glasgow bug. Yeah, Ati, but think about it. If you look at it like this, that's still valid framing, right? So it's not unique. So I need a character that guarantees framing errors. So basically FF, but then some transitions, right? So like maybe this will work. Like if it's one, I need a low and then like FF might work. Or not. That doesn't work on going faster. Probably because it takes a while to lock on. No. Yeah, alternating might work. No? I'll just try a for the hell of it. That's probably not going to work, but... Why all the zeros? I get the feeling there's actually a little bit of a Glasgow bug here. See, like, sometimes it works and then sometimes it doesn't. Oh, wait. No. See, when it doesn't work, it gets a bunch of... So, hold on. First of all, I'm going to turn off TTY because this is annoying. And then... Yeah, it's estimated, so the baud rate is a little bit off. That's fine. It's expected to be slightly off. Yeah, so like what happened there, right? So I did set baud. This is the ASCII text. This is the number, 115,200, ... new line. And then Glasgow interpreted like FFFC, 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 and then C5, what is supposed to be 5C. See, so that's getting it backwards. So again, that's a framing issue there, right? It picked it up backwards. There has to be some character that works for this. Actually, wait. So there's got to be some UART framing that works. So we know there's like 0 and then 1, right? Yeah. But then why, like, shouldn't this work? Shouldn't FF work, right? Because then it's got the transition, right? Or does it need more? Does it need adjacent edges? Or is it 0? Does zeros work? Maybe 0 is the ticket. Nope. What happened there? FE? Oh, is that because when you go to the lower baud rate, that 1 is interpreted as a as a whole packet, and then it went to 0 anyway, so that's fine. Oh wait, yeah, that's the packet header. Crap. Wait, hold on. Yeah, okay. Well, we tried FF and that didn't work. No, that's fine anyway, but... So what happened there? Wait, hold on. That should be fine. Why did that fail? That looks correct. Oh, hold on. My packets start with FF. Do I have a... Oh, that might just be a bug then in my code. Oh, that's why. It gets FF. Then it doesn't get 5. Oh, that's why. I have a state machine error. Yes, yeah, okay. This is fine. This is broken. That's why FF doesn't work. If it is FF, then this looks... Yeah, and then you've eaten 2 bytes. That's why. Random address? What random address? I don't think I posted any random address. Yeah. How do I want to do this? If basically... what's the right way of doing this? I guess I just need to skip that. How many continues? Are those the only? Yeah, that's the only place it continues. That's fine then. And there's always a return at the end. Yeah, that's fine then. Okay, so then just if reply, do a plus there. Kind of buggly, but actually I can just do it this way. If reply -1, then get that, else cool. Yeah. Huh? Yeah. Nope. Not that, sorry. There we go. Still breaks. Wait, what happened there? That's not right. That's fine. No, something else is going on. FF5? How'd that happen? How does that end up in FF5 now? No, something else is wrong. Is it possible that FF isn't triggering Glasgow's... Yeah, because FF is a single low bit, so it triggers a start bit and it doesn't. I think it doesn't trigger the auto baud always. Like if it's only a short bit or something, it might not be triggering the auto baud properly, and then it triggers like here or something, and that's when it breaks. Okay, so hold on. So let's do it like this. Let's improve this. Doesn't it have the same problem where it can be framed in two different ways? Like you have a 0 at the beginning, so then you can... Wait, does that work? Oh. You know, that has a second valid framing. that bit pattern is the same as this bit pattern. It's not working. I have a lot of wait. Yeah, see, like FF itself is showing up as FF, but not enough times. Like, I'm supposed to be saying 256, and I'm only seeing a few here. Somehow. Like, I think it's still interpreting these as 115k baud, somehow. I think this could be a bug. Like, it should be discovering the baud rate change from a single low bit, and it's not. Well, anyway, clearly we need more than one thing, so let's just, like... Yeah, that manages the time. I mean, of course, I could just wrap it and try again, and it would be fine, but... let's make it a 32-bit pattern, and then we're good. It doesn't help that, like, my magic number for the UART stuff is literally those bytes. Like, I thought that was a good idea at the time. So... But, yeah, let's do it, like, F5 and... 5A, A5... 0 or something. I don't know. If it's that complicated a pattern, hopefully it will work. I think we're fine. Yeah. It needs to be more than one byte pattern. Otherwise, it's too easy to get confused. Cool. The problem with 5.5 and AA is that because all the bytes are next to each other, you don't know where a byte starts or ends. So it gets the baud rate right, but not where the characters start and end. And then the next byte after that gets corrupted and triggers a framing error, and then eventually it catches back on, but it's too late. If I had a delay, if I sent the pattern and then waited, if I introduced delays, it would be fine. But that's another thing I need to figure out is the timers, because I need a delay function. Okay, that was enough time wasted on that. Let's go to... I would eventually want to flash this one, actually. But I think I can live without it for now. Yeah, so all I was doing is here, I don't need it to be that long. I'm going to turn off this print. Probably 16 is enough. Okay. That's fine. Where does that come from? Where do those Y's come from? Huh? How did I break the state machine in reply? Oh, wait. Yeah, that. No, it's fine. Okay. So next up, that just makes my test cycle nice and fast. Device trees, I guess. I'm getting hungry. I should get some dinner. I should Uber Eats something. Hold on. How long have I been streaming? Does it say? Does it say how long the stream is? 5 hours? All right. So yeah, let's look at the device tree. Another thing that I need to do is exception vectors. But we can do the device tree first. Oh, I have a snack upstairs, actually. Let's see. So there's a Linux version of this that is documented. Ah, thank you. Let's see. So this is the macOS version. Oh, restruct is I didn't realize. So this is a construct style thing, right? Have you used both? I've never heard of this one. All right, so it's a tree with node, property count, child count, properties, children, and what's the Linux version like? I'm curious to see if it's similar at all, the flattened version. Where's... I know this is documented somewhere. Not the ABI. Is that what it is? No. I thought there was a doc for this, and like, hold on. Not the findings, but... Oh, it's just the directory, okay. Ah, there we go. Well, actually, there's going to be a nice HTML somewhere. There we go. Oh, it's still... Huh? What was REST? Oh, Okay, whatever. Give me a second, I'm going to get a quick snack because I am very hungry. I can eat this while reading up on device trees. Should probably mute the mic so this doesn't become an eating stream. That's pretty tasty. It was a chocolate eclair from 7-Eleven. New thing. DT strong. Yeah, so the Linux ones use separate strings and structure things, right? All right, so I need some code to parse these things. So one thing I'm going to look at is my asbestos stuff, because if I make the API similar to the Linux device tree API, it'll be a bit easier to read. I thought it was in here. No. The thing is, like, this all, it isn't my GitHub. Like, some of this stuff got moved to other drives, and some of this stuff, like, in weird places. So it should be in stage 2, and libfdt. I hope the license on this is sane. Okay, so it's BSD or GPL. That's fine. How manyth iteration of Raider? Well, let's see. That was... I got that when I definitely named the machine when I was studying in the US. So then And so then that was the Athlon 64. And then it became a Core 2 quad. And then it became my Core 2 Duo laptop. That's 3. And then it became the new laptop I got, so that's 4. And then it became this iMac, so it's 5. It's the 5th iteration of Raider. Though it's the 5th iteration of machines with the name Raider, but the actual OS install didn't have, like, it didn't have a host name. It was something dumb. It didn't have a naming scheme host name. So if you count that, there was a previous Athlon 64 that it was in. So it's the 6th iteration of the OS install, but it gained the name Raider in the 2nd. Actually, I'm just going to look at how I use the code. It's in kernel.c. Yeah, so this is, I'm going to have to use similar code in Mini to do similar things. So thankfully, I don't have to make anything editable. It'll just be like this. But if I make the API the same, it's going to be a little bit, I don't know, at least familiar to people who need to deal with the Linux ones. My perfect math class. Petit boot? Isn't petit boot just Linux? The petit boot's just Linux, right? That's not useful. Like userland code. All right, so let's see. Let me make a little API for this. So looking at Shiz's code, this is just, I mean, the structure is basically the same, right? You got nodes, property count, child count, properties, children, and then a property is a name, size, value. And then the print node, props. Wait, hold on. Is the properties have a name though, right? Is that just the name property? Is that what it is? It is. It is just a name property. Okay. Yeah. Cool. And there's no metadata. It's just size value. Okay. In that case, that should be a pretty simple API. So I can just have like a... What did I do here? So child's size is not stated then, right? Just child count, and then so you have to actually have to iterate through the entire thing down to the property count level to. No, wait, not even that. So everything's linear. You have to parse everything from the top down to see anything. That's kind of annoying. It's fully serialized. You can't jump around. Nee. That means for every single lookup I make, I'd have to, if I don't convert it to a Saner format, then for every single lookup I make, I have to parse it from the top down, which is not great. Then I will convert it to some kind of data structure. So, new device tree, let's call it, it can be the same thing, because we'll write it into a buffer. It's nice to have this in buffers, and I can probably just hard code the buffer size or something. Because I do want to add malloc to this bootloader at some point, but I don't think I want to do that before I parse the device tree, because there's stuff about memory addresses in there that I want to know about. So let's make this device tree parser not use dynamic allocations. Let's see. So this is the API. It's going to be open into. So let's just use the same thing as same names as this one. Glasswell has 16 pins, so in principle you could do 8 I2C buses at once if you had the applet for it, which you don't, but you could do that. Why would a bootloader need a malloc? I mean, you can write one without a malloc, but it's convenient to have malloc sometimes. Actually, what are the read-only ones? I think, yeah, because the thing about the Linux one is I think the Linux one can actually. Yeah, I think this is more of a saner API or something, but because the Linux device trees, as I was looking at earlier, where'd it go? Here. The structure one does. No, so this is linear too. So does the FTT do the same thing and actually just linearly scan the whole thing for every single lookup? If you don't do the load stuff? It might. Yeah, so this is also just a linear scan. Next node, is this go through the whole thing? Or is that defined? Yeah, it literally goes to the whole thing. Should I just do it the same way then, for now, instead of avoiding a realloc? I mean, if it's good enough for the FTT, it should be good enough for us, right? Right? Let me just see if there's any docs about this needing linear scans and if they recommend it or something. Yeah, that thing, DTC. Documentation. Clearly some things got improved too. It's larger. Manual. Not useful. Whatever. I mean, it's an M1. It's fast as hell, right? We can afford to have some n-squared issues in the device tree parser. All right. So let's just not do open into. Let's just do it as a scan. So let's do this. Let's make this emulate the read-only API, which is going to be like this. So yeah, we're just gonna have implement a subset of this API. Path, again, path offset. It's like 64. It's like yeah, like this thing is like sorry, yeah, it's like 300K. It's pretty big. But depends on how much stuff we have to copy from it, right? If we only need to copy a few properties, and the way the API works is you look up a node and then you look at subnodes. So it's not like for every single, like it depends on how you use the API. If you want to dig down manually or if you want to rescan the whole thing for a path. So it's fine. It's not going to be an issue. Mostly. But yeah, I'm just going to clone the API because that way there is some consistency to this whole thing. So we get return structure block offset with a node that's running path on success. Yep, and then let's call this XDT. I need that function anyway. I'm basically actually just going to copy this code and change the implementation because why not, right? It's going to get Clang formatted anyway. I probably don't need get name. I am going to get the name properties out, obviously, because that's how this works, but that's fine. We'll see what functions I need to implement. I'll just copy them for now. Let's just do a full API copy. Get property by offset. Yeah. Probably don't need namelen for that. What's that W thing? Oh, is that just writable? That's a hack. We don't need that. Well, I don't know if I need all these functions, but for now I'm just going to include everything, and then we can delete stuff we don't need. But then this, yeah, this extra stuff we're going to skip. We just don't want the basic structure management functions, because there's no special. So, okay. Now the question is, should I license this one under BSD because I'm kind of copying stuff from libfdt? It's probably a good idea. That way I can just copy the code and change it. Though, to be fair, I mean, those licenses are compatible anyway, right? But yeah, I want to copy the code anyway too, so. The question is, like, can you... Yeah, like, it'd be like weird dual thing anyway. And GPL is any... Yeah, let's do that as speedy x. There's this p. Make sure I get the expression right on that. Hold on. Make sure I get the expressions right on this. Yeah, basically that. Except this or later. Hey, Kate actually knows these identifiers. Cool. I'm not converting FTTs. It's not useful to convert the Apple FTT to the Linux FTT because there will be too many differences. What I need is an API that can let me extract specific information from the Apple FTT and then manually insert that into an FTT. we absolutely need to maintain our own DT copies because it's not going to be the same as the original Apple device tree formats. Like the drivers are going to have different bindings. We're going to be using Linux drivers that are generic. We're going to be that's not going to work. The way we use device trees is going to be, it's the same idea, but it's completely different from in all the details from the way Darwin is going to use these device trees. The models are similar, but we're not like. It's not just p handles. Like there are going to be Linux drivers that already have device tree bindings that are different from the Darwin device tree bindings, and we need to convert that anyway. We can't patch Linux to like magically support every single device tree. That's not going to work. We are already maintaining device trees. There's no way around that. Believe me, that's not going to work. Like there's no way. Nah. Why am I doing that in C? Because this is going to go into Mini. Well, yeah, like we're going to have, like, for example, if I want a simple frame buffer for the, like, that's not even in the device tree, right? Like, I need to get the frame buffer information from the Mac boot information structure and insert it into the device tree. So that's one change that we need to make, right? But like, there's also the entire chosen section of the Apple device tree is full of garbage, and like the way CPUs are defined is different, and like there's no way this is going to be useful. Like there's so much. Like, look at this thing, right? Like, first of all this garbage under device tree, and then. Like, we're going to have ARM, like, generic ARM things defined here. And also, there's, like, PCIe, like, XHCI. Like, this is not going to be the same as however Linux handles this. And then, like, for example, the UART, right? This is a Samsung, UART1 Samsung thing. That's not going to be the same driver name as Linux uses. And then we probably need a property that is like an Apple variant, right? Drivers TTY serial. Where is that thing? Samsung. This thing, right? DT match is where? So it has to be Samsung, comma, and some specific UART, and there's different versions, right? And so this is different here. We have UART1, comma, Samsung, and then like we need to add something that says like this is Apple, right? Yeah, just add the compatible string, right? But then it's like, okay, so then we start making changes to this, and so what? I end up with a pile of C code in Mini to convert one device tree to another. Like, no, like the GPIO subsystem in Linux has nothing to do with the GPIO subsystem in Darwin. I'm sure it's not just hardware. This isn't going to work. How am I going to add this compatible string to the Linux driver? UART1, comma, Samsung. Like that doesn't follow the pattern. It doesn't follow the spec. That's ridiculous. I disagree with your approach, and I will stop listening to you now because you're not going to convince me that this is a good idea. I am so sorry. Exactly, I need to upstream this. It's not just about yeah, no. We need to maintain our own device tree, and also most of the stuff here is garbage anyway. Not anymore. No, they're not. like this was the case back when it was the open firmware stuff on PowerPC, but this is different. Like in the ARM world, Linux has completely made up its own device tree definitions that nobody else cares about because it's all done for Linux. And so, like, look, let's look at a random boot, like for a device tree, right? Like a Tegra device tree or something. It's very different. Let's look at the CPU, like PCIe, right? Like PCIe here. It's Dart APCIe for starters, right? There's like it's called APCIe because it's an Apple PCIe controller and it's different. And now, like, compatible APCIe T8103, okay, fine, but you know, like power gates is not a thing, right? There's clock names and reset names here. And this is called clock gates and power gates, which is different from, like, Linux uses a clocks thing. It doesn't use a clocks gates property. And like, the ranges is probably going to be different anyway. And then, like, look at how interrupts work. Like, this is probably going to be different from this, right? And then GIC. And then there's a reg names thing here that like, they don't use. There's no reg names, right? So we need, like... No, it's not the same thing. Ranges is standard, but like names is not. Fine, but what about the clocks? The clock names and reset names are not the same. There's Linux subsystems that are at a subsystem level, not at a device level, not at a driver level, not at a device-specific level, at a subsystem level, define device tree conventions that did not exist when this was forked off of open firmware. And it's not going to be the same. No, it's not going to work. Trust me. I've written device trees. There's no way in hell it's going to end up compatible. It's going to be, if I go that way, it's going to be like, you know, a pain in the ass. And then eventually we're going to decide it was a waste of time and a stupid idea, and we end up with our own device trees anyway. Look at I2C devices. We have the TI controllers. We have Linux driver for that. It's not going to be defined the same way. Like, where is that? It might not even be in there for all I know. I2C, speaker, audio codec output, AQC, HPM bus manager. Yeah, here we go. HPM is what this is called, right? What was that thing? The TPS... I forgot what it was called. 65982. Is it not there? I thought Linux had a driver for some version of these. Yeah, this. Oh, does it not have device tree bindings yet? That's possible. Oh, it does have it, yeah. TPS 6598X. Maybe we don't have any device trees for that yet. As an example for that, is there any... This is not a waste of time because this is actually like useful to see how this works in the device tree. It is an example anyway. Yeah, so it looks like this. I2C 698 compatible Type-C con connector. See, this goes into the Type-C framework on Linux, right? And then if I look at the way Apple does this, it's nothing like this. There's an HPM bus manager, compatible USB-C manager, and then that contains HPM0, which is called CD217, which is not the same chip, even though it's similar. And like this, look, pin control is not a thing here, right? It's a completely different structure. This is not going to work. Okay. I hope I've established why I'm doing things this way. So yeah, we're not converting device trees. Everything exposes USB-C to the OS. And embedded, especially. I mean, the only way to handle that is like AXP and messes which don't exist here. Linux has USB-C drivers for this reason already. Anyway, yeah, so I might listen to you. Are we calling this XDT or ADT? That's one thing I might give you. What do you guys think? Should I call this XDT for GNU or ADT for Apple? Which one do you vote for? I'm not calling it AXDT or XADT. Looks like ADT is winning, so I'm going to go with ADT. ADT it is then. Because it's not saved yet. Okay, so let's see how much of FTT I can use for this. This is BSD2 clause, right? Yeah. That's fine. Anyway, anyway. Okay, so Is this actually, by the way, is this padded, or are the nodes also like? Because that's really annoying if it's not padded. It looks aligned. Yeah, it looks 4 byte aligned at least. Yeah, it's definitely 4 byte aligned. Okay, cool. This is literally next node, as in the one, then that doesn't work for this. Because I don't. Yeah, this is traversing the tree, which is not what I need. So the innards of the API are going to be different. But then this is just going to be no depth because it's bringing the same depth. And then I can just do it like a first child thing. So what I do is... Yeah, this is going to be a recursive call. With this assume I know there is a new sibling. So this. Actually, that can just be a that can probably be inline too. Let's not do variable length arrays. Actually, no, yes, let's do it because we return those anyway. That's fine though. Actually, we would call that as first property offset, next property offset. So why is it a len p? Is that just because the FTT is? Oh, it's just because that's kind of redundant, isn't it? to match the API, to be honest. Is this big Indian? No, it's little Indian. And length is the length of the data, I assume. Yeah, that's fine. This length thing is kind of dumb, to be honest. I'm tempted to just delete it. Why do they have the length thing all over the place? Oh, is it because the properties don't have the length? No, they do, don't they? Tagline, it's in there. Oh, well, get prop makes sense with the length, but not the others. So this, I'm going to ignore that nonsense. Slightly change the API. Yeah, these make sense with the LNP. As these are just variants on the same thing anyway. Why is it a pointer to a pointer? Oh, okay, it returns the name, sure. This can be not inline. Well, we won't need it anyway. We just copy most of this wholesale. This code would pretty much work just as is, I would say. What's the string? What is that thing anyway? Why is this not just steer comp? Oh, okay, because of the partials. Yeah, that's fine. We need that. That's fine. And we don't need that. I'm just going to assume normal endianness now. If this ever needs to work on big endian machines, we'll worry about it at that point. Cool. String of name off name. It's not. We don't need that though. We don't use that. So we just need. len a equals len and then comp a b len equals 0. Yeah, that's what I want. By offset, I'm going to reuse their error codes because I can. Honestly, that's never going to fail anyway. So what's the point? No. Okay. So here's the plan. Alex had a point about maintaining from scratch device trees. But I have a point that doing the translation in Mini is stupid. So what we're going to do is we're going to maintain device trees for all Apple devices. And Linux doesn't have to deal with any of this stuff. This ADT thing in Mini is only so that we can get information that iBoot passes us that is not in the hard-coded device tree. However, potentially we could have a few, like if we know there are multiple devices with a very specific difference, then we could avoid having multiple copies, but we'll see if that makes any sense. But the thing is, but Alex has a point that there's a lot of information in the Apple device tree that we can programmatically convert into a Linux device tree. So what we're going to do is we're going to build offline tooling to manage Apple device trees. So we can collect Apple device trees from all Apple Silicon devices, diff them, find the changes, and automatically convert certain things into Linux device trees. In other words, we're going to have like a bunch of Python scripts that deal with all this stuff so that we can efficiently maintain a Linux set of device trees. But it's not going to be an automatic process that you just run a script and everything is perfectly done into Linux, which is what doesn't make any sense because that's a lot of work. It's a lot more work to do it in C even. But it does make sense to automate the maintaining the Linux versions of the device trees to some extent. And so we're going to have completely offline Python tuning at some point to help find differences in Apple device trees. And if we see like patterns that change very often, we can write code to convert the formats and convert the the different structures in ways that make sense. And that way, that's a completely offline thing. It doesn't have to do anything to do with user devices, and it's it can be written in Python, and we can do whatever we want, and that's all going to be great. And the only thing dealing with Apple device trees in end user devices is going to be Mini, and it only needs to do that to get certain information that it needs to convert into that needs to insert into the Linux device tree at runtime, like memory sizes. Yeah, they're saying that I might want to read the ADT at runtime and make sure some hashes equal. Well, the problem is that there's parts that vary, so it's pretty hard to remove the parts that change, I guess. But I get the feeling that because the device tree is shipped with iBoot, which comes with macOS, Apple is probably going to do the same exact thing. In other words, they're going to update the device tree as they update their kernel with different needs. The hardware doesn't change. So that's actually doesn't make any sense for us to check the device tree because it's going to be different for every macOS version. The only thing that might matter is if the device tree contains information that varies depending on which version of iBoot is installed, which it might. And that might be something to check. But it's kind of hard for us to tell at this point exactly how this will work on the Apple side, like what is likely to be a problem and what things need to be dynamic, what things need to be static. So we're going to be refining this as we go. And like having these APIs allows us to implement specific things in this conversion in Mini where it makes sense. For example, things related to the firmwares of different devices might be in here, or versions or whatever. But what we can and will do, of course, is that the device tree has a header with what device this is, and we need to make that's how we decide which Linux device tree to use. So yeah, so obviously we'll be checking that, and if it's an unknown one, then we can just throw an error or something. But also, it makes sense for Mini to be able to load its own device tree supplied by the user in case like the built-in ones don't work, or maybe we can. I don't know if we want to build in the device trees in Mini itself, or if we want to have them in a directory next to Linux. We'll see how we want to do that eventually. Probably makes sense in a directory just to allow people to update them more easily. Since we only need the Linux device trees when we actually boot Linux, so that can just be in the same partition as the kernel. And that way we can easily add new devices without having to even build new binaries. Next to Mini doesn't make any sense because Mini is an APFS partition. And we don't want to have to parse that. Let's start building this. Yeah. Actually, I might not want libftt just yet. I just want the error codes. But honestly, we don't even have most of these errors anyway, so what errors are we going to use, if any? Probably not many. Probably just not found. So let's just add whatever we need. All right, so what does check header do anyway? Are there any sanity checks worth doing? That's just the main. Yeah, it's not useful. We can check that it's a device tree, I guess, but oh, the name isn't even here. That's annoying. The name should be. Yeah, it's in there, but it's not obvious to search for, so we're not gonna do that. No checks. All right. So get property name, it should work fine. Get property name, yeah, that's fine. These are just doing the same thing. Get prop by offset. You want that, yes. So get property by offset. So what I'm going to do is np if np, and we don't need a string for that. So wait, was the length inclusive or not for the property? So it's just the size, I assume, right? Yeah, it's just the size. Value with size data at D, that's the partial thing. Shiz, am I right here? That It's name, size, value, and size is just the size of the value. I don't know restruct. So size is not inclusive of name or size. Okay. Yeah, and I guess we can sanity check that a little bit. Oh, where is that? Where was that function? Did I delete that by accident from RO? No. Oh, internal. Name is no term. It's no pad at least, right? Unless the length is, yeah. Oh, the high bit is set. Do you know what this high bit means? Well, I'm hoping the name isn't going to be 32 characters. Do they actually have names that are 32 characters? One second, toilet, while you check for that. Yeah, anyway, the only thing that's going to happen if the property is not terminated is that we'll fail to match the property if we ever have to look for a 32 byte one, and we don't care. Even if it like, as long as we don't look for such a property, it's not a problem. I don't want to complicate the code. Like, it's not even going to be a bug with a new device tree, unless we need to actually look for such a property. All right. So much junk. Yeah, it would help if I include my... And to be honest, I can just do types.h here. But I guess this ADT thing is going to be useful outside of mini, so I shouldn't use mini types. For ADT, I will use only standard int types, because that way this code is portable for other things. Time for ADT prop const by ADT. This is getting in instruct ADT prop const. I need a constant here. So many errors. Wait, I don't have Sterling here. Oh wait, I don't have Sterling? That's on a mission. That's funny. Yeah, I don't. I mean, I know all these functions are easy to write, but you know, I'm just making a pattern of copying these things from the public domain C library because it's easy enough, and we know they're correct. Let's go back to that. ADT properly name len. Is that the lenp thing? Yeah, we don't need that anymore, do we? Everything with property, I don't need a name. Get prop. That one is useful. So much fail. Okay, and the high bit is on the size you said, right? Yeah, that's interesting. Then we need a... Let's put a bit of guarding on these things. By the way, I think I'm going to call it a day when this device tree parsing works and I get the watchdog timer and UART information from the device tree. Well, not UART yet, because I don't want to do that quite yet, but at least the watchdog timer from there. So that's going to be today's goal, is getting this to work. Oh, that's why. And then get property by offset. No lenp here. Get property by offset. Value, not data. Node, it's and then we have offset redeclared. We don't need int, just change it. First property, next property. Let's call these the same kind of style. Actually, did FTT call it like that? It is next node, but that's a traversal function. Yeah, it makes more sense to call this like the. All right. FTT check header. We want this ADT check header. Getting somewhere. Offset undeclared. All right. So what's this doing? Yeah, def1. Okay, yeah. So, but obviously, what this needs to do is just get the first child, and then if why is that a separate function? Oh, because of the p. Yeah, okay, we need that. We need memchar. Yeah. Let's see. Name EQ short match. This is kind of ugly, but fine. So it checks for that. If p if alen equals 0 to 1, I need memchar. I was wondering if I would need those functions. I guess I do. That should be fine. Okay, so if ADT node name EQ and then if not found, return that. So not offset name then. Actually, there was an editor config thing for making it eat trading white space. So I probably want to use that. I have some editor config for this thing, but I want to make it a bit nicer. Yeah, let's do that. Makes it a bit nicer to edit. Or not. Or not. Huh. Oh, I thought that worked. That's weird. Yeah. Well, I'll leave it in there anyway. We'll see what happens. Maybe I actually need to reopen it. No, yeah, like a refresh works though, so. No, I don't know. Whatever. Worry about it later. Or is it only when saving? Oh, yeah, it's when saving. That's where it is. That's fine then. Cool. Subnode offset name then. Subnode offset. That should just be with a strlen, right? Yeah. We can call that parent offset. That's fine. It's offset. Path offset. We're not going to do aliases. This should be the same. What does that do anyway? Actually, we should check that the this is aligned. That's probably a good idea to have in here. check node offset. So if offset sensor or offset percent. And let's just do a simple sanity check on those headers. You know what? Well, it's internal, so. That should work, right? How big are we going to allow our device trees? Two megabytes should be good enough. Let's do it like that. That should be up to, what, 16 megs or something? Should be enough of a sanity check. Or if the size is... The node... Are empty nodes allowed? No, there has to be a... Oh, sorry, not size. This is a property. This should be in check prop offset, sorry. Prop size... Empty size should be fine for properties, but not the number of nodes, so... Yeah, this should be fine. And this should be a line 2. .7fc. Actually, wait, no. The property says there's no way the property is going to be that big. So let's just say up to 1 megabyte property should be enough. There's no way a single property is 1 megabyte. And then for nodes, let's check the alignment, get the node, and if node property count is more than something child count. Hopefully that's enough. Why are they calling this get node offset thing? This does error, but then it doesn't use the offset anyway, so why? What's the point of that? That doesn't, it's not useful. Okay. On the compile run. We're gonna at least define these to be compatible so things don't explode if I mess up and use the wrong one. These need to be ADT. And property count always needs to be at least 1 because everything needs to have a name, right? All right. If class does not guard. Oh, you know what that is, right? That's the go to fail sanity check because it's interpreting my tab as 8 spaces. It's seeing this and saying you're making the go to fail mistake. All right, memchar. Where did I go here? A. If there's no P, no B. If there's no at in B and that's 0, that's fine. Yep, cool. And that's not P, that's A. Then check header FDT should be check header ADT. And then there's an undeclared int I. And use the variable child. Yeah, we don't know. That's not useful. Subnode offset namelen. Yep, looks good. Right, it says name, so that doesn't work. So they need a name, not child name. So I need a property thing. How do I get property? Do I have a get property thing yet? Yeah, ADT get prop. Not offset name len p. Two few arguments. Why does that have len p anyway? Oh, because yeah, it's const. But actually, that API is kind of dumb, isn't it? It's void. You know, it's void. Yeah, that's fine. That's fine. It's fine. Yeah, that's fine because it's a string. We don't need the length for that. And actually, we don't need the child. That's fine then. We need strchar also. I'm sure someone's saying, but just use the new lib or something, and I only need string.h. I don't need anything else from a C library, and I already have a separate vsprintf, and I'll get a separate malloc. Like using those embedded portable C libraries is always more pain than just like for embedded coding. All I need is I don't need standard IO or any of that nonsense. I just want vsprintf so I can have a printf that works. That's one file. Malloc, which is another file, like dlmalloc or something, and then string.c and string.h, which is what I always end up copying from the bydomain C library. Like, those are the 3 bits of a C library I care about for embedded coding. Cool. ADT get name. Oh, that's a useful thing to have written, isn't it? Do we want an NP for that? Probably not. Standard int.h is not a C library issue. That actually comes with the compiler. So you get standard int.h by default anyway. That's just the GCC header. Yeah, some of those can be built-ins with like memcopy and memset can be compiler built-ins, but you still have to provide the implementations because that's not a guarantee, right? And the compiler can choose to inline them or not, depending on what it's doing and what platform it is and everything. So you can't rely on the compiler having magic memset and memcopy and those things. FTT again. Should actually just do a wholesale replace of FTT. Live ADT. Not that one. All right, getting there. And that's the one I don't need the lenps in there. Actually, wait, I don't need any of these things. I already have those implemented. Does it compile? It does. Okay, cool. And so let's see if this works. So for example, the watchdog timer should be in well, the first node is device tree, and that's a pain in the ass. So we don't well, that's not work. Hold on. Path offset. So for everything we got a subnode, and we're already, yeah, that's fine. Because that goes first child. So it is going to ignore the device tree thing at the beginning, which is what we want to look like Linux. However, that does have properties, which is fine if we need those. That's just offset 0. That's fine. Let's see if there's anything useful here. Oh, this is interesting. Compatible is like, is it using, is it like 0 separated? Oh, it is. Okay, because it's a list of strings, I guess that's how they implement those. Yeah, that's fine. I'm not actually going to use most of this anyway in minis, so. All right, so let's see if and I should just have just have that in there, and when the boot stuff and startup, we can stick that in there. Didn't we have that already in main? This thing, yeah. We can just use that for everything. I'll probably move this to somewhere else, but so in principle, if I just do ADT get prop, actually, isn't there a function for this already in libftt? Name then, was there a path or not? VT get path. I need like a non-nameland version of that actually. Wait, hold on. This is a different thing. Path offset, and then it was. What is that doing? Oh, determine default path. That's not what I want. Yeah, path offset. Yeah, that's fine. Okay, it's the same API then. And this is the root node, so in fact I only need the I only need get prop. Because it is the root, so. Cool, that should work. Let's do a bit of info printing here. That should be good enough for now. Wait, hold on. Is it possible that that top bit on the size means it's a string array? Cheers. No, it makes sense, right? No, that's not it? Okay. It looks like a compression thing, right? Sysconfig regen / hex20 0 / hex20. Like, it looks like it's some kind of yeah, like some kind of look this up in sysconfig, otherwise return zeros, like language, right? It looks like it's some kind of indirect reference or like something look up in sysconfig, comma, default value, and that top bit tells it that it should interpret it like that. That would kind of make sense. Yeah. Well, we probably don't care about that. We don't even know where sysconfig is. That's kind of interesting anyway. Like, it should come from somewhere. Is that? I wonder if this is like from those files in the like in the hardware subdirectory in there. Anyway. Get brought by offset. Why is that not defined? Shouldn't be static. Not inline. It isn't there, yeah. Cool. Model device. All right, anything else interesting here? Probably not, but is there anything interesting chosen? I like how it's like cover glass color. But yeah, this makes sense that it's the per device thing, which also might mean that iBoot doesn't insert any device-specific information at all in the device tree. Oh wait, no, this is, oh, that's right. No, sorry, this that must be that. So maybe all these things might go away, right? Like, because this is the image4 thing, so that makes sense. So this is telling iBoot to replace all these properties with random things. Like, are there any of those top bits set by the time we get the device tree? That makes sense, right? Have you tried looking at the device tree I pasted, the URL earlier? Because maybe we don't need to care about the top bit if we're not parsing those raw device trees. Did that link make it? Because I've had link issues before. Cool. Yeah, and that's why the libftt API. I mean, I will implement malloc later, but right now I don't want to require malloc to parse the device tree. It feels like it's a good idea at this point to not need that. That was an old question from half an hour ago, by the way. So torrential target. Yeah, so then we don't need this thing here. So well, I'm going to leave it anyway because it might be useful. But it's good to know that all that goes away. So let's see if there's anything interesting in Chosen. Same color. Cover glass material. Like, it's so Apple. Display corner radius. I like this one. Disable AV content protection. I sure like to set that one to on. Can you imagine us getting us in trouble with Apple because someone like implements a mini patch that just turns this on and then chain loads Darwin and like people use this to pirate Netflix or something somehow? Like it's Mac address Ethernet 1. That's going to be useful actually. And this is just like dummies, right? Yeah, it's just dummies to fill in with random crap. That's why they use these things, because all the properties are fixed length, so you can, in fact, just insert things. That's how they patch it in iBoot. And memory map reserves is the same thing, right? So memory map is actually useful to parse. Hold on. Okay. Since I don't have restruct right now. Chiz, can you paste the output of your parse somewhere? Just save me some time. CTRR isn't here. That's good to know. But there's no This isn't here. SMP options, CPUs. Yeah. Anyway, that's all fine. So anyway, what I need is /arm.io/ is it in the tree? Yeah, it is. WDT. So it returns that. And then the nodes on this are, I need to poke, what was the thing there? This 1C in there to 0. Which I think is not actually a separate tree, so I just need to add it. And also, I think the property, I don't know if this is 32-bit or 64-bit properly, hold on. Reboot UUID? Yeah. That sounds useful. What's wow about that? Yeah. Oh, you were gonna look for the, like, those are the NVRM stuff, right? This is just in chosen, right? Yeah. Oh, there's a whole NVRAM proxy data structure, right? So that's probably like the whole NVRAM or something. And there's also boot manifest hash and all those things. Oh yeah, random seed, by the way, is useful. We need that to initialize the Linux hardware random number, software random number generator, and to do KSLR and all those things. Yeah. So the WDT. Wow, so is the WDT reg really missing the top bits? Like, how does that work? It really is, isn't it? They are in fact 64 bits and they're missing the... How does that work? So I thought it might be 32 bits or something, but no, they're 64 bits. So does it have to add it to the ARM IO? Oh yeah, there's a board ID in chosen. And there's a unique chip ID, which is not it. And there is a chip ID, 8103. So that is literally hex. Interesting. So let's put board ID and chip ID here. Can we like get prop? Let's do it manually. Oh, I need chosen. Should probably add convenience functions for getting these things properly, but oh, I need these in the header file. Is there... useful errors for... There's no bad length. I'll just make something up. Here. Yeah, sorry, use STRP, yeah. But I want to do this differently anyway, so... Actually, what I want to do that is... It sounds like a better API anyway. This feels more like C, so let's do it like that. Otherwise it feels like C++. shouldn't really be a size T, since everything is ints anyway. Hairbreadth length. So return len. And we're here. Get yeah. This is sounds like a reasonable API to me. Should not paste garbage. Yeah. So the other problem is that why is there no 2 in there? Well, for now, that's fine. Let's see how badly this explodes. And of course it explodes. It's dead. Actually, I should add a reset command in here. Have that thing. Not... it is running, okay. Right here. I think it's actually just dead. Yeah. Not sure why, it kind of dies sometimes. No, it's fine. So... no. Renamed that and it's stuck in my history forever. Let's make a binary. Not that, but let's call it a reboot. Not short. Actually, I want to add a udev rule for that because yeah, quick yak save. So that's and the Arduino thing. It's just a CS341, so I guess we can just call it that. There's like, yeah, there's no ID on this, is there? Mildly annoying. Where'd face transfer go? Is it in late? Yeah, here. Okay, so... What? What? Did they just do a weird Vim mode or something? Huh? Oh! Okay, Kate is eating that key. That's annoying. I guess I don't need... it would be useful to do ID vendor. One is... probably check for drivers too, just in case. Nope. No, not FTD. That's making fucking sense. That's it. Nope, that didn't work. Maybe it needs to be the same. Let's get rid of the drivers just in case. Current UAZ sending 6040. That works. Yeah, reboot works. Okay. So let me do, well, baud rate, setting the baud rate unconditionally is not a problem. So let's do, what was it? Set baud? Set baud. Huh? Oh, is that not flashed yet? Did I not implement that yet? And I didn't flash the one without that yet. That's annoying. Okay, let me do that first. Prove that this works first. Yeah, that's fine. And then I can set baud. Yeah, that's fine. Cool. So quick fix on this. And flash it. Oh. What's going on here? Make Android terminal. No. The UART. So there's two things here. I have the face dancer, which is one UART used to emulate the keyboard and the mouse. That's a different thing. Then I have my USB PD interface device, which is an Arduino, but has its own UART, and that's what I use to send USB PD commands. And then I have a Glasgow plugged into the other pins on the Type-C port that has the actual UART. And so I have 3 different individual devices connected to the Mac Mini, 1 via USB on one of the Type-A ports, and then 2 on different pins of the Type-C port. Eventually, those 2 will be one design I make when I have some time to make a production version of this. So it's different things right now. But yes, effectively, the PD bridge, as if you consider it 2 different devices, is exposing 2 different UARTs in different ways. Okay, there we go, that. And in principle, I can just chain load that with the logo and everything, and it works fine. Yep. All right, now let's get rid of that. Oh, there was no. Oh, I forgot the watch. No, I didn't. Ah, shit, I did. That's a problem. I need that at least. Whoops. I can see the number of viewers falling. I guess people are getting tired. While that works, print info in there. You know, I'm not getting the bong anymore on reboots, but I used to. And now I'm wondering if that's something they changed in beta 2, like some change in iBoot, where on reboots you don't get the bong anymore, only on hard power-ons. Why is that auto-completing? Huh? Oh. Hmm? Oh, reboot, sorry. Yep. Yeah, it doesn't do the bong anymore. That's interesting. No, they didn't get rid of the startup time. The startup time is there. When I power it on cold, it does the bong. But now not on reboot anymore. Yeah. And they brought it back. And now, like, it seems it was gone. They brought it back on every reboot, and now it's only on cold boots or something, which is interesting. Yeah, sorry, I replied too fast. Yeah, okay, so let's see what's dying here now. ADT, get prop ADT. I need some debugs on this thing. Let's see what I broke. Should probably do a debug. So the first thing I'm doing is adt get prop, which does this namelen thing, which does this that, which, okay, so hold on. Yeah, should be like that. Is that in util? I think so. Util is... No, it's just string. UART? That was utils for the define, right? No? Yeah, but I should import. No, the printf isn't there. Sorry. All right. So it does go as far as init property namelen. Actually, I should be printing those in hex to make my life easier. That doesn't look right. Those offsets are not aligned. Oh, I bet the numbers. Yeah, is that how it works? Are they just align to the next? Yeah, align to. Yeah. Okay. That makes sense. Don't I have an align macro for this already in utils? Or in types? No, I have stack align and stuff. That's why. Cool, it works. That was the bug. That was the only bug, apparently. But that just failed to find chip ID, but it did find chip ID, so obviously there's something else that is stupid. Less than 0. It doesn't keep switching baud rates randomly. It switches baud rates when it fails, because it's going to boot at 115K and then switch when I chain load the new one. And new lines. Cool. Should put some more new lines in here. And so now I can find the watchdog timer device. And well, but you can assume it's at least but it says not Python. What did I just break now? The path thing is broken, I guess. No, because that worked. Did it die? Maybe reg is... no, that should be fine. No, that's fine. That's C. That is perfectly valid C. I do need a new line there. Oh, that might just be breaking the TTO. No, it doesn't. Does it get this far? Let's enable debug again. I like this test cycle. When it dies, I just reboot the thing, and by the time I do the next test, it's back. Cool, I get the node and then property name, and that's where it fails. Why? I'm gonna add some quotes here, so that's cooler. TTY. I just read the letters out. It does get it. Okay, so it's just a get prop thing. Oh wait, is that the MP? No. It goes there. Oh, is it just is this oh, it's unaligned. It's unaligned. That's gonna be why. I bet it's unaligned. Yeah. Unaligned address. Most likely. It's because this is only aligned to 32 bits, even though this is a 64-bit, that's why. So it's actually failing down here. The ADT code is fine. It's failing here because we don't guarantee alignment here. So would probably be useful to have a get prop 64 or something like that at some point, but for now this will work. Copy. Lots of warnings though. Oh, that definitely not. That's not gonna work. Cool. Okay. So, but now that's the issue is why is that like that works, right? Wait, hold on. That's not right. One C, sorry. Yeah, no, that is right. Yeah. That's interesting. Well, I wonder what that is. It's in the same range as the oh, that's the watchdog counter, isn't it? Cool. So now we know, that might be a useful timer actually. But yeah, so where does that 2 come from? Where, like, why that? Look at the txt file you pasted. Where was that? Oh, it's on this side. Yeah. Interestingly, it says socket generation H13, which is what was that called? Like that's like A14, right? So it doesn't even show up as M1. If you're still watching, Alex, do you know about this? Like, I'm only getting 3D 2B from the reg property. Oh, wait. Oh wait, so I need to. How does that work? How do I know which ranges? Yeah, it's that one, obviously, but... Oh, is that how it is? Is it just relative to the... Right. But which one of them is... Which one of these ranges is... Are they just, like, adjacent? Anyway, I think I wanted to get the device tree parsing code to work, and that does work. And this is just standard device tree stuff. So I think I'm going to call it a day, besides it's 1 a.m. here. And this was quite productive. So I guess I'll see you all next time. But I think this is pretty good. Like this test cycle is very, very productive, so things are going to go pretty fast from now on. All right. Thank you, everyone, for watching. And, yeah. I get the feeling that things are going to be pretty fun from now on. How long was this, anyway? How long is this string? Seen that? Like 8 hours, right? Cool. All right, well, good day or good night to everyone. It was fun, and see you around.